Hi, good afternoon, everybody. My name is Matthew Botel. I'm Assistant Division Chief for the Industrial Strategies Division here at CARB, and I want to welcome you to our July 20th workshop on national working lands and our approach towards target setting. So I really want to just take a moment to thank everybody for being here today, and also, for those of you that participated in our June workshops, both to kick off the scoping plan process and the follow-on workshop we had the day after to talk about natural and working lands. I want to appreciate all of the comments that you've submitted. We have over 100 comments on the comment log, and we're working through those and looking at those, and those are definitely going to inform the work that we have here in front of us today. I also wanted to just take a moment and recognize and call out the team here. So you're going to hear presentations from Adam Moreno and Alex Yu, who are staff in Industrial Strategies Division and really doing a significant portion of the work here on target setting and the approach to target setting, as well as Shelby Livingston, who many of you know has been really central to this effort on national working lands for many years. We also have staff available from our Air Quality Planning and Science Division, who have been working for many years now on developing a national working lands inventory, who you're going to hear from, as well as tribal representatives and hopefully members of our EJ Advisory Committee. So with that, I'm going to hand it off to Dr. Adam Moreno, who's going to lead you through the presentation today, and really look forward to an engaging discussion. Adam, take it away.
All right, thanks, Matt. As Matt said, I'm Dr. Adam Moreno, and I'm leading CARB's natural and working lands modeling and scientific efforts for the scoping plan update. So just before we begin, I want to say that we are recording today's workshop, and we'll make the recording accessible via the scoping plan webpage after this workshop. And today there will be a couple of opportunities for public comment and questions. And so all attendees currently are in listen only mode. And when we get to the public comment period, we'll ask attendees to raise their hands using the raise hand button. They indicate that they want to make a comment or ask a question, and the meeting organizers will unmute the attendees so that they can be heard. There's also a 2-week public comment docket open. Anyone may submit comments at the URL on the scoping plan meeting and workshops website through August 3rd. So it's a 2-week period. Before I kick off the presentations, I'd like to take a moment to recognize our tribal partners. In recent times, collaboration between tribal nations and the state has grown and continues to grow. And each era of California's history has brought different atrocities against tribal peoples, including land dispossession, discrimination, cultural impacts, and loss of life, just to name a few. To this day, many tribes continue to mobilize to preserve their culture and fight for restoration of their rights and lands while forging new roads towards equity and autonomy. This trajectory reminds us that the march towards justice is at times fraught with long chapters of struggle. Tribal nations and indigenous people in California have been sustainably managing lands for generations and are in a unique position to offer insights on ways to protect the environment. We thank our tribes for the knowledge they create and share, and will work to uplift their efforts to protect, implement, and build upon traditional, ancestral, and ecological knowledge and practices for the betterment of all of California. We hope our meeting today and our ongoing efforts with tribal nations will help better incorporate tribal viewpoints and the voices of tribal communities in decisions made in the state of California. Today's workshop will be 3.5 hours. We will hear from a tribal government representative and representatives from our Environmental Justice Advisory Committee. We will also hear about CARB's Natural and Working Lands Carbon Inventory, which will be used to track progress towards our targets. And then the majority of CARB's presentation will consist of explaining the approach we are contemplating for target development. Within this portion, there will also be comments from the Environmental Justice Advisory Committee There will be a midpoint open Q&A session and a 5-minute break. And then the second half of the workshop will be dedicated to public comments, questions, and discussions. We encourage you to please take advantage of this comment period to give us feedback and suggestions on how we can improve. We understand that this workshop is being held during a time that is inconvenient for many throughout California. And for this reason, we also ask everyone here to please let others know that would be interested to know that they can find this presentation recorded on our website, and that there's a public comment docket open. And so in this way, hopefully, we hope that those that cannot be here live will still be able to be informed in this process. We'll end today's workshop by providing information on next steps and provide you all with information on how you can stay engaged. There are multiple objectives for today's workshop. The first is to share with all of you CARB's concept for quantifying a natural and working lands target. Second, we would like to receive feedback on any portion of our presentation today. Third, we would like to answer questions you may have. Today is a technical workshop. However, it is still our objective to make everything understandable to as many of our audience members as possible. So if you have a question, others probably have the same one, so please don't hesitate to ask. Additionally, this is simply not enough time to explain all of the science that is going into this work. So if we have not explained something in depth enough for you, please let us know. And in that vein, our final objective is to allow all of you to have the opportunity to help shape CARB's natural and working lands technical work at the ground floor. Here, I would like to thank all of the other state agencies that have been working hard to contribute to this work. The information they have collected and analyzed has either already or will inform the work I'm going to present today. So thank you to all of those civil servants and public officials who are out there helping us out. Briefly, to orient folks who may have missed the kickoff meeting a while back, to date in our climate efforts, we focused on limiting emissions from burning fossil fuels and releases from high global warming potential gases. In planning for carbon neutrality, all sources of emissions must be balanced by sinks by mid-century. Fossil fuel production and consumption has induced the climate-related problems we now face. So the first priority remains minimizing combustion of fossil fuels and driving down emissions from other sources as much as possible. But we also need to develop and utilize carbon sinks. And this includes both engineered technologies as well as naturally occurring carbon removal and storage in our natural and working lands, which is the topic of today's workshop. Our lands provide an important opportunity to use nature-based climate solutions to remove carbon from the atmosphere and store it over the long term to help limit the effects of climate change and meet our climate goals. However, it's important to recognize that natural and working lands are both a source of emissions and a sink. Recent catastrophic wildfires, land conversion, and other disturbances that are largely driven by climate change and human activity can drive our natural and working lands into a net source of emissions, which makes achieving carbon neutrality even more challenging. Okay, so what do I mean when I say natural and working lands? California's natural and working landscapes cover approximately 90% of California and include rangelands, forests, wetlands, grasslands, farms, riparian areas, deserts, and settlements. And settlements include vegetation in urban and rural communities and around other developed lands like roads and energy infrastructure. These places provide important and significant environmental, economic, and public health benefits to the state, supporting clean air, clean water, wildlife and pollinator habitat, recreation and exercise, sustainable communities, tribal communities and practices, and they provide food and fiber and strong economies. They are also a key component to the state's climate strategy. Keeping these lands and waters intact at a high level of ecological function, including resilient carbon stocks, is critical for the well-being and security of Californians through 2030 and beyond. Now, as we plan our climate strategy for lands, we must balance our efforts on climate with the many other benefits that these lands provide. So CARB will not set a carbon target so high that other important ecosystem services degrade to the point that communities and nature itself suffers. Enhancing or improving California's ecosystem services, including carbon sequestration and stocks, will be accomplished through a suite of nature-based solutions, which are actions that work with nature to help address societal changes and recognize that healthy ecosystems provide benefits on which we all depend. So today's workshop will discuss CARB's plans to quantify a carbon target and how it can be achieved in an equitable way through nature-based climate solutions. Additionally, we have been directed by the governor to update the scoping plan, taking into consideration the California Natural Resources Agency's Climate Smart Strategy and the California Department of Food and Agriculture's Farmer and Rancher-led Solutions information. Natural and working lands has been a part of California's scoping plan since the first scoping plan in 2008, actually. At that time, however, only forests were considered, and only one study was used to determine a target. So this 5 million metric tons of carbon per year was set without regional perspective or adjustments to the results of the original scientific study. The science of nature-based climate solutions was relatively rare relatively new at that point in California. The next scoping plan update in 2013 recognized the need for all lands to contribute to California's climate smart strategy or climate strategy. And so the term natural and working lands was developed. This scoping plan called for a more thorough look at forests, which resulted in California's Forest Carbon Plan. The Forest Carbon Plan does not set any new targets, but does provide a lot of valuable information on actions and mechanisms that California can use within forests to help achieve whatever target we all may set together. The 2017 scoping plan update took the next step toward developing a comprehensive natural and working lands carbon target. Through the process of updating the scoping plan, CARB, along with the California Department of Food and Agriculture and the California Natural Resources Agency, developed the Natural and Working Lands Implementation Plan. The Natural and Working Lands Implementation Plan examined the mechanisms and actions that can be taken throughout California. And through this effort, it was calculated that California could reduce emissions from natural and working lands 15 to 20 million metric tons of carbon per year by 2050. All of these numbers, however, were somewhat at the periphery of the scoping plan because the focus of these scoping plans was, for a good reason, the reduction of emissions from fossil sources. However, it is now clear that reducing emissions is not sufficient to fight climate change, and we have been ordered to determine a path to make California carbon neutral by 2045. And when one moves from emissions reductions to carbon neutrality, that requires taking into account the whole carbon balance, including the carbon dynamics within natural and working lands. So for this reason, CARB is increasing our efforts to quantify a natural and working land target. And in this scoping plan update, CARB will set new carbon targets for natural and working lands. As we go forward in this fight against climate change, the state of California is taking action with and trying to learn as much as we can from our tribal partners. Indigenous people have been managing lands throughout California since time immemorial, and we will continue to learn from, take action with, and incorporate tribal insights in how to manage landscapes in a sustainable way that can make our ecosystems more resilient to change and to the changes that we're going to experience in the future. So I'm pleased to introduce an expert in this space, Javier Kinney, who will speak with us on how the Yurok tribe has been approaching these challenges and key lessons California can apply as we go forward. Mr. Kinney is a Yurok tribal citizen and currently serves as the carbon project manager for the Yurok tribe. Mr. Kinney has extensive experience advising tribal governments with expertise in areas of natural resource management, climate change and resiliency, public policy, economic development, youth empowerment, land acquisition, tribal governance, grant management, protection of tribal and cultural resources, strategic alliances and partnerships. And with that, Javier, take it away.
Good afternoon, and thank you, Adam, for the introduction. I appreciate the time to share today with this webinar. The three areas that I'd like to cover include tribal governments and partnerships engaged as decision makers within the Natural Working Lands Forum. Secondly, to encourage partnerships and strategic alliances with the state of California, as well as philanthropic foundation, industry, and other tribal communities. And third, and most importantly, for those involved in space, to continue to support nation building, tribal sovereignty, and self-determination. As Adam mentioned earlier, my name is Javier Kinney. I am a Yurok tribal citizen. The Yurok tribe is located in northwestern California in both Humboldt and Del Norte counties. And our tribe has made a distinct and thought leadership aspects in regards to how the Yurok tribe is engaged as a decision maker within the natural and working lands, not only with the state of California, but with our federal agency partners, as well as our international partners. One of the approaches the Yurok tribe takes on and considers very important from our tribal leadership and our staff is the ability and the opportunity to include traditional knowledges regarding our forests, lands, and waters. As you may know, or if you're not aware, the Yurok tribe is engaged in various initiatives along the Klamath River, as well within our ancestral territory. Our ultimate objective, again, is to purchase or regain 1.5 million acres of our ancestral territory. And this includes having a diverse economic as well as natural resources portfolio. This includes dam removal initiatives, natural resources management with our forests, as well as fisheries and water protection, condor reintroduction, as well as cultural resources protection within and near the ancestral territory of the Yurok tribe. Secondly, we've also found that working in collaboration with other landowners, industry partners, as well as the state of California and our federal agency partners, is that solution-based approaches can go a long ways. This includes not only looking at the collective and holistic natural resources interface of ecosystems, but not necessarily always providing the recognition for tribal governments and tribal communities to engage in these processes. Thus, these partnerships and creative alliances can assist in not only returning ancestral lands to tribal governments and tribal communities, but again, setting the lead in not only the thought leadership and dynamic and innovative approaches for our federal government as well as international partnerships as we continue to see the various global citizenship membership grow. And so these finance as well as climate partnerships will help us create the solutions that will be needed to create this not only dynamic, but exciting future. And third, and most importantly, we continue to encourage all of not only the state of California, but our industry partners, as well as our academic partners, environmental justice advocates, as well as other tribal communities, to continue to support the nation building efforts of natural resources within the state of California, including land, water, wildlife, as well as the various skill sets that we can bring to the table to be able to encourage and participate in these economically sustainable initiatives and activities. The self-determination, not only for the Yurok tribe, as well as other California tribes in the state, can provide that skill set, the ancestral knowledges and traditional knowledges, as well as the scientific expertise that will assist us as we move forward. But with that, I'll also be available for questions and appreciate this opportunity to share those remarks.
Great. Thank you, Javier. Lots of good information there. So let's go on. Okay, now to have success in achieving a carbon target, one has to have a way to measure progress. CARB has been tracking carbon within natural and working lands for several years using our carbon inventory. The carbon inventory is the backbone of how CARB will track the state's progress within natural and working lands. So I'd like to introduce Megan Miranda, staff in the CARB's emissions inventory section, to discuss CARB's natural and working lands carbon inventory. So Megan, take it away.
All right. Thank you, Adam. Now let's dive into all things inventory, starting with some history. So in 2006, Assembly Bill 1803 transferred responsibility for maintaining a statewide greenhouse gas inventory from the California Energy Commission to CARB. Simultaneously, the California Global Warming Solutions Act of 2006, also known as AB 32, designated CARB as the lead agency to address climate change. Now, 10 years later, in 2016, SB 859 tasked CARB with also creating and maintaining an inventory of ecosystem carbon on California's landscape, and hence the Natural and Working Lands Inventory was born. Now, let's talk a little bit about what this inventory does and what it's used for. First off, it provides an estimate of the ecosystem carbon that exists on California's landscape and how those carbon stocks are changing. This is called tracking stocks and stock change. The inventory also attributes stock change to human activity, such as land use change or disturbances, such as wildfire. This approach helps to inform CARB not only about how much carbon is where, but also why carbon stocks are changing. As such, the Natural and Working Lands Inventory is an important tool for tracking the impacts of interventions, such as projects funded by California climate investments and bond funds. It's also used as the foundation for future scenario modeling and target setting. Really, it shows how California's land base contributes to the state's climate goals. All right. So CARB's Natural and Working Lands Inventory has specific features that allow it to meet the policy needs of California. It's geospatially explicit, which is just technical jargon for it shows how much carbon is where. It covers all of California, not just a specific region or land cover type. And as mentioned before, it tracks changes in carbon stocks and land cover over time. Finally, it tracks carbon not only by land cover type, but also by carbon pool. There are 4 main pools tracked in the inventory. The first is above ground biomass, above ground live biomass, which would be things like leaves and tree trunks. And then you have below ground live biomass, which just means roots, dead biomass, so this would be things like fallen trees or forest litter, and finally you have soil organic carbon. Tracking by land cover and carbon pool helps CARB to understand how it can most effectively use the California land base to meet California's climate goals by painting a holistic picture of where the carbon is, if and how the stocks are changing, and why. Okay, so the underlying framework for doing all of this work is called the stock difference method. The stock difference method estimates the gains and losses of ecosystem carbon and indirectly the exchange of carbon between atmosphere and the land. The idea is that you estimate the amount of carbon on your landscape at 2 points in time and take the difference, hence stock difference method. One of the ways to represent the overall change in carbon stocks is to, so here we have stocks at time 1. We have some shrubs, we have a young live tree and some dead stuff, and it amounts to about 100 metric tons on the left. Later, at time 2, we see that this tree is a little bigger. There are now new trees, some more trees, and some other additional dead stuff, and maybe we lost some. Maybe a wildfire happened. But now we see 1,000 metric tons of carbon there. So the stock difference method tells you there was a net gain of 900 metric tons of carbon over this time period. Okay. The Natural Working Lands Inventory is based on the IPCC methodology for greenhouse gas inventories, which I know is a mouthful, but that's its official name, and tracks changes in ecosystem carbon by land cover type and how land transitions between land cover classifications. So there's 6 main classifications identified by IPCC. First, we have forest lands, which in the California inventory also includes shrublands. And then cropland, developed land, wetlands, grasslands, and finally a catch-all category called other lands, which really just takes everything that doesn't fit into the other 5 categories. It'd be things like rock outcroppings or desert lands with little to no vegetation on the landscape. For each inventory time step, a location is identified as being in stasis, which would be something like forests that were identified as forest at time 1 and at time 2, or as being in transition. So for example, a forest that was converted to an orchard or a cropland. Carbon on the landscape is then assumed to have different rates of accrual or loss based on whether the location remains in stasis, so forest remaining forest, or it transitions, so that forest converted to cropland example. Land cover types in this inventory are identified using the Landfire database, which is a satellite-based data set made available by really a large consortium of federal agencies. And then this data set is mapped to these 6 IPCC land cover categories using methods that were created in a research contract between CARB and UC Berkeley. Final results for the inventory are reported in these stasis and transition categories. Okay, without further ado, let's actually look at the inventory outputs. So on the left, we have a spatial inventory of carbon stocks for 2014. The light tan areas have relatively low carbon stocks, and the dark green have the highest carbon density. And the dark green areas are where one would expect there to be a lot of carbon, mostly in the Sierra and northern coast forests. So this just kind of makes sense on a base level. These maps are produced for each inventory time step and can be used to visualize where the carbon is increasing and or decreasing over time, in addition to simply showing how much carbon is where. So moving on to the map on the right, we have a map of disturbances by acreage, and this is for a pretty long time step from 2001 to 2014. And you see that the vast majority of disturbances for this time period are from wildfire. It's at a whopping 74% of all disturbances by acreage. And the remaining quarter are other forest management practices such as thinning or prescribed fire. And changes in ecosystem carbon stocks are attributed to these disturbances, which tracks the major drivers of stock change on the landscape. Okay, and now we have tabular inventory results for 2014. So the sunburst diagram on the left shows that the overwhelming majority of carbon in the California landscape is in its forests. And about half of that is in soil and about half in biomass. Forests make up 85% of the total inventory carbon, with the remaining 15% in all 5 other land cover categories. On the right, we can see changes in carbon stocks by pool over time. Soils and biomass in forests, grasslands, wetlands, and otherlands are shown to be losing carbon from 2001 forward. But the good news story is that California is gaining carbon in both its urban forests and its croplands. Being able to look at changes in carbon stocks over time is a particularly powerful tool for the state of California. And please keep in mind that these numbers will change with the new inventory publication that is coming out later this year. Okay, so let's wrap up the inventory piece with just a little bit of housekeeping. CARB has 2 separate inventory ledgers, one for ecosystem carbon, which is the natural and working lands inventory, and one for emissions from direct human activity, which we're calling the AB32 greenhouse gas inventory. The natural and working lands inventory quantifies ecosystem carbon stocks and stock change in biomass and soils. What's included are carbon stocks associated with those 4 main pools we discussed earlier, above and below ground, live biomass, dead biomass, and soils. Methane from wetlands emissions are also quantified under this ledger. And the natural working land inventory does not quantify soil inorganic carbon because this carbon pool is recalcitrant, which just means it changes so slowly that it's not, it doesn't change quickly enough to track. Carbon stocks in submerged ecosystems, so in this example, it'd be things like seagrass meadows, are currently not quantified due to a lack of data. But biomass and soil carbon for emergent wetland systems, such as tidal marshes, are included. Also, avoided emissions are currently not included in the inventory. The AB32 greenhouse gas inventory quantifies emissions from direct human management of the landscape. So examples of this would include fertilizer applications and crop residue burning, or emissions from animal husbandry. And these emissions are counted towards the reductions goals set forth in both AB and SB 32. So now that we've covered what the inventory is and how it fits into the larger framework of CARB's climate change efforts, I'll hand things back to you, Adam. Thank you.
Great. Thanks, Megan. So now I'd like to explain CARB's proposed approach to target development for natural and working lands. I would first like to take some time to talk about what CARB means by natural and working lands. Essentially, I would like to define what is included in our natural and working lands work. Hopefully, by explaining these boundaries, we can clear up some confusion about what we are considering within natural and working lands and what would be included in the AB 32 GHG inventory. And Megan just partly explained this during her inventory presentation just now. And we are matching our goals, our targets to our inventory, which itself matches IPCC methodology. And so this is all to ensure that progress towards a target can be tracked in each natural and working land type in a scientifically accurate and consistent way. Some parts of our definition are pretty obvious, but other parts may not be, and some are cross-sectoral and may have to be considered in both the natural and working land and fossil emissions strategies. So on this slide, we can see a list of what we are considering within this natural and working lands boundary. So here we have lands and wetlands, perennial vegetation, on-site carbon stocks in live and dead plant biomass and soil, carbon fluxes associated with photosynthesis, respiration, and decomposition, essentially just what's being sequestered or emitted, biomass carbon stock changes associated with natural disturbances, and carbon stock changes associated with actions that directly change biomass or soil carbon stocks. Also, harvested wood products and vegetative waste. And within the whole life cycle assessment of harvested wood products and vegetative waste, at some point that becomes cross-sectoral and crosses over into the AB 32 side of the calculations. Next, I'd like to explain some general principles that we are using to direct our processes and methodologies. First, a natural and working lands carbon target will have to include emissions and sequestration rates, or that is to say the amount of carbon that is being taken out of the atmosphere over some period of time, and carbon stocks. Or said another way, the amount of carbon in plant biomass and soils at any one point in time. And so in this way, we are trying to ensure that we are not encouraging some management strategies that may just increase sequestration rates or just maintain current carbon stocks, but instead strikes a balance between these two because sometimes they're competing efforts. Second, we will focus on ecosystem benefits and impacts as a whole. So that's to say, we do not want to maximize carbon to the detriment of other important ecosystem services that California relies upon, such as water, fire resilience, food security, recreation, biodiversity, and a whole host of other things that people and nature require from these systems. Carbon will be an important part of the target setting process, but will only be one consideration that will be addressed. Third, the carbon target will reflect regional priorities. And as I will explain shortly, the carbon target will be influenced and informed by federal, state, regional, and local policies and management priorities, goals, constraints, and ambition. That leads into our fourth principle, in that CARB is not predetermining a carbon target and then figuring out how that can be achieved. And this is in large part because we are evaluating biological systems that we can influence, but that we are not in direct control over. As such, we want to first understand the potential carbon stock outcomes based on the underlying biological system, and then understand how those outcomes can be shaped by how you all want to manage landscapes. CARB is not a land management agency, and so we are looking to those that do manage lands to inform us how you will manage your lands given your ambition to fight climate change and make your systems more resilient given an uncertain future. Our fifth principle is, of course, that we will utilize the latest science and publicly available data and models to do our work. Our sixth principle is more of a practical or operational principle, but California is an extremely diverse state in terms of ecosystems. And modeling even one system in a way that takes into account our uncertain future under climate change is a very technically complex task. So that being said, we are having to prioritize our time and resources. And this prioritization is also scientifically based and follows the carbon stocks found in CARB's Natural and Working Lands Carbon Inventory. So the inventory shows that 85% of carbon stocks are in forests and shrublands. And so 85% of my time is devoted to these lands. And this is not a ranking of how important we think natural and working land types are. We know that they are all important, and we are working on all of them, and we have some practical limitations to our resources. Finally, given our resource limitations and our passion for this topic, we commit to always improving every aspect of our work through time. And if we can only cover a portion of a natural and working land type now, we will, with time, work towards giving every square mile of California's natural and working lands the consideration and technical work that it deserves. Okay. Sorry, I've just kind of my boundaries thing. Sorry about that. Okay. So the carbon target that we will be discussing today is only a portion of the larger California-wide carbon neutrality strategy. As I have already mentioned, a portion of CARB's focus on combating climate change remains on reducing emissions from fossil sources as much as possible, as fast as possible. Our parallel work on natural and working lands will help CARB and the rest of the state better understand the magnitude of emissions or sinks in natural and working lands, as well as the co-benefits that come from implementing nature-based climate solutions. I hope that through this presentation, those that are not very familiar with the natural and working land sector will come to appreciate that changing carbon emissions and sinks within natural and working lands and modeling those changes are fundamentally different from regulating and modeling other sectors. So, for example, we as a society have more control over fossil emissions. These emissions relate, for example, to how we utilize electricity, how we drive our vehicles, what kinds of vehicles we drive. However, we do not have complete control over biological systems or the carbon cycle as a whole. Additionally, the carbon cycle takes decades to centuries to make certain sorts of improvements. Many aspects of the carbon cycle can only moderately be impacted by management. So in natural and working lands, management cannot solve all problems. And often those improvements that can be made take a lifetime to achieve. Further, as lands are typically managed on local scales, such as on the watershed scale, we will need to think about these lands in those terms. And the carbon dynamics that we quantify through the exercise I'm about to present will inform the natural and working land component within the overall target setting for carbon neutrality, combined with the traditional sectors that have been the primary focus of previous scoping plans. And so before I begin to explain our approach to target setting and our modeling, we cannot lose sight of what is actually needed from this effort for carbon neutrality. We need to understand carbon stocks and fluxes, emissions and sinks, so that we can assess how things change moving into the future. We also need to understand what will happen to these carbon stocks if we take no action. We need to understand how we can change future carbon through action. We need to decide upon what a target will look like. So that is to say, what are we talking about? Carbon stocks, fluxes, acres, something else? And we have ideas about how to answer these questions, which I'll present in the rest of the presentation. The process that we develop must be repeatable so that we can always improve and respond to changing conditions. And then ultimately, of course, we have to identify a carbon target for all natural and working lands across California. So here's a diagram of our proposed target setting process. In this diagram, 3 purely hypothetical alternative natural and working land scenarios are depicted. Each natural and working land alternative has statewide and regional policy objectives in the blue boxes, a mix of management strategies in the green boxes, which will lead to ecological outcomes through our modeling process. Then this feeds into the mechanisms pathway, which will determine the policies needed to elicit the identified change in management strategies, which will estimate the cost of a scenario. Then when CARB is done with all of the analysis that underlies each of these boxes, all of the alternatives analyzed will be assessed with our state agency partners and presented during a public process. Staff, based on state agency and public feedback, will ultimately propose a scenario and natural and working land target to our board for inclusion in the final scoping plan. And as you can see, hopefully, but don't worry if you don't, because I'm going to explain this diagram for the next 30 minutes or so. This process begins with the objectives that everyone has for managing the lands of California in the blue boxes there. And from there, through several steps, we arrive at a carbon target. So not the other way around. For this next section of the presentation, you'll see this diagram in the upper right-hand corner of the slides to indicate where in the process we are that I'm talking about. So first, let's talk about some definitions so we're all on the same page as I go about explaining this process. I will define these terms here briefly, but we will deep dive into each one of them in subsequent slides. The first term to define is policy objective. A policy objective is a jurisdictional goal on how lands are managed into the future. This should be the ends that are desired in terms of on-the-ground management. Examples of policy objectives could be treat 1 million acres of forest and shrubland per year, or increase cover crops by X%, or increase urban canopy cover by Y%. Next, a management strategy is an overall approach to on-the-ground land management, including where, when, and what type of actions occur. So examples can be thought of in terms of how a landscape, not a single plot of land, is managed. Like within a watershed, thin 100 acres every 3 years, prescribed burn 400 acres every year, clear cut 80 acres every other year. And then next, an action. And an action is an on-the-ground activity that alters the landscape. A management strategy is made up of individual actions. And examples of actions can be thinning, clear cut, prescribed burning, cover cropping, planting, etc. A mechanisms pathway is a portfolio of levers that California can use to elicit the desired changes in management strategies, like legislation, incentives, regulation, etc. Examples of specific mechanisms could be ecosystem service markets, conservation easements, biomass products and fuel incentives, subsidies, etc. And finally, a natural and working lands alternative scenario is a set of policy objectives, management strategies, and mechanisms pathways. Okay, now let's dive deep into each one of these steps. First up is policy objectives. As I've said, the policy objectives that we are considering are trans-jurisdictional and span statewide to regional scales. What we would like to get here are the actual objectives that you want to result from any policy that you are promoting or hoping for. So that is to say, for your region, for your natural and working land type of concern, what are you hoping to accomplish with the policies you are promoting in terms of on-the-ground action? It is policies that change on-the-ground action which changes the carbon dynamics in some way. So in this effort, we are focusing on policies that change on the ground action, because it is through these policies that change how we can actually combat climate change and the impacts from climate change. Okay, said another way, in this step, we are looking for action-oriented policy objectives, not funding or assistance objectives. That is to say, we are trying to figure out how you want vegetation and soils to be managed going into the future. So if you are thinking primarily about deregulation or increasing funding for a specific program or whatever, we are hoping to get this framed in terms of the ends that will result from those means. If you are going to comment later on regulating something or funding something, please let us know how you want this to change on the ground management, ideally in terms of actions per acre per year, ideally. So for example, if you want increased funding in the Healthy Soils program, frame it in terms of how many acres of cover cropping you might expect from your desired funding increase. Again, for this step, we are trying to focus on the ends, not the means. In this way, we can start out with our aspirations for the future in terms of how we want lands to be managed without first getting bogged down by funding or bureaucratic hurdles. That comes later. To that end, here we would like to get as specific as possible, because this is going to direct the management that will be modeled. And we want to ensure that we are capturing your vision of the future in our modeling as accurately as possible. This first step in the process will determine how aggressive you may or may not want to be in contributing to our collective challenge of fighting climate change. In your natural and working land type of concern, in your region, so if your natural and working land type of concern in your region collectively wants to do everything you can to contribute to this cause, please let us know. If your natural and working land type in your region has no interest in contributing to this global effort, also let us know your thoughts. We will be looking to your comments, both from previous work and moving forward, for guidance on this topic. So significant effort has and continues to go into understanding federal, state, regional, and local objectives. Input into these past and current efforts will help inform what scenarios, what management strategies eventually get modeled. And this is a list of a few of the efforts that have already been made to collect information upon which we will draw to get a sense of these policy objectives, excuse me, I was just talking about. All right. Now, after we have determined a few scenarios of how California's natural and working lands could be managed going into the future, given our objectives, we will then determine what the ecological outcomes of that combination of management strategies will be. And we have a two-pronged approach to determining California's natural and working lands ecological future. First, we are conducting a literature synthesis or meta-analysis. And a synthesis or meta-analysis is similar to a literature review, except it is systematic, and you actually extract data from those papers to do a whole new analysis. This step will serve multiple purposes. First, it will ensure that we understand the state of the science on this topic. It will ensure we are doing our due diligence to include all of the amazing science that has already been done in this area. It will also ensure that we're including all the great work that many of you have participated in to help us collectively understand nature-based climate solutions. And here we will actually do two syntheses. One, to understand what the current published science says about future projections of natural and working lands in California. And the second, to figure out how the future could change given different actions. The synthesis will answer three key questions. One, given all current research, what is California's natural and working lands future climate benefit or liability? What are the most promising combinations of actions to explore? And what is the best possible theoretical carbon outcome given the natural and working lands trajectory from the first synthesis about projections and the most beneficial actions that can be taken? The synthesis will also help inform us about actions that may have the greatest carbon benefit and so should be highly considered within our modeling, which brings us to our modeling approach. I and others will explain the modeling in greater detail later in this presentation. However, this is to say that additional modeling is needed so that we can, one, determine the scenario that maximizes carbon while also providing the maximum possible co-benefits for other sectors, vulnerable communities, and California as a whole. And two, allow for CARB-specific policy and management scenarios. All right, now I would like to pass the mic to Alex Yu, and Alex is a staff air pollution specialist at CARB and is co-leading the synthesis effort. So to explain more about our synthesis process, here's Alex to take it away.
Thanks, Adam. So as just mentioned, these two meta-analyses represent our due diligence to synthesize the current state of the science on natural and working lands. This is how we operationalize the previously mentioned principle of using the latest science. The results of the meta-analyses will be incorporated into the scoping plan and provide valuable context for the natural and working land targets we present in the scoping plan. In the meta-analyses, we will be extracting quantitative data from existing research in peer-reviewed published articles, compiling the data, and analyzing results to establish a range of carbon stock projection estimates. These estimates will vary by natural working land type and activity type depending on the available research data. The first meta-analysis will be focused on future projections of the effects of climate change and other global change factors on future carbon pools and GHG fluxes in California natural working lands. The resulting range of estimates by natural and working land type will be used to check the CARB projection modeling results, which will be discussed in detail in a few slides. CARB's modeling results would be expected to generally agree with the long-term trend estimates from this first meta-analysis. The second meta-analysis will look for data on the effects of specific land management actions on future carbon pools and GHG fluxes in California natural working lands. This meta-analysis will result in a range of carbon stock impacts for individual land management activities, such as no-till agriculture or adding compost to croplands or forest fuels reduction treatments. These will help inform which activities to model under our scenarios and provide another check to modeling results. CARB staff have already started on these efforts, so next I will provide an update on the status of each of these meta-analyses. So the general process for each meta-analysis is depicted in this diagram. We begin with a keyword search in literature databases that specifies geographic, land cover type, climate, and carbon outcome criteria. We also use citations to and from several seed papers that epitomize what we're looking for and that we know for certain are relevant. Articles that meet the search criteria and that come from the seed papers are then put through a series of screening efforts to gradually filter out irrelevant articles. We begin with a title screening, which screens out the majority of irrelevant papers. Then we screen the abstracts to further filter studies. Next, we read through the text of the papers to identify the most appropriate ones to include in the synthesis for data extraction. For the future projections meta-analysis, we began with over 15,000 initial articles and have filtered them down to 242 relevant articles. We are currently in the last stage of synthesizing the data into meaningful results. For the future projections meta-analysis, for the action impact meta-analysis, we recently started this effort, and therefore we're in the earlier stage of screening the abstracts from over 7,000 initial articles. Over the past several months, we have been engaging with several stakeholder groups on both these meta-analyses and have received numerous suggestions on studies to include. We are still seeking suggestions for papers to include, and we hope to include all suggestions into our screening process. Hopefully they have already been included in our broad search, but we want to be as thorough as possible, so we appreciate any suggestions for existing peer-reviewed published articles. You can send your suggestions to us through the public comment docket. We aim to have the results of these meta-analyses in time for incorporation into the scoping plan update. While we are still synthesizing results for the future projection of meta-analysis at various landscape scales and by natural and working land type, we would like to share the preliminary results for the studies that modeled statewide carbon stock changes. So these studies projected all natural and working land types across all of California into the future and included the effects of climate change and disturbance. This graph shows carbon stock change in million metric tons from 2001 levels. It does not show CO2 emissions. So going down is bad in terms of losing carbon stocks on the ground. The gray shaded area represents the overall range of estimates from all of the studies. The black line represents the weighted average of the studies. This weighting is used to ensure that each study is weighted the same no matter how many scenarios each paper includes.
You're muted, right, Alex?
Is that better?
Yes, now you're back on.
Okay.
Back at the yellow line.
Keeps muting me for some reason. Okay.
Hey, Alex, we're getting a lot of feedback on your end. Adam, is there any way you can continue the presentation from here?
Yeah, sure. Tag me in. Okay. So in this diagram here, the yellow line shows the carbon stock change from CARB's natural and working lands. All right, let's see. Okay, let's see if I get muted again. All right. The yellow line shows the carbon stock change from CARB's natural and working lands inventory. And there's strong agreement between CARB's natural and working land inventory okay, interesting. Having the same problem as Alex here. And I've got no background noise, so. All right, I'll just continue. I guess keep trying to unmute me as I go. Let's see. All right, so as I was saying, or trying to say, there's a strong agreement between CARB's natural and working lands inventory and the short-term projections from the meta-analysis studies, at least so far. And as we proceed with our modeling work, we will use this chart in addition to the other forthcoming meta-analysis results to at least have a gut check on our new modeling results. All right, moving on. Okay, so as I was saying now, the synthesis will help inform the modeling of the overall target. And now I want to introduce the modeling component of our work. So modeling of alternative scenarios, alternative natural and working land scenarios will come after we have determined the policy objectives in our overall target development process. Once we know the policy objectives, we can develop management strategies to fulfill those objectives. The management strategies across all regions and natural and working lands will make up a portfolio of strategies to fulfill a specific alternative natural and working land scenarios policy objectives. So these management strategies are actually what will be modeled. The purpose of the modeling is to quantify the ecological outcomes that result from the management needed to fulfill our objectives. Here, ecological outcomes refer to future carbon stocks and fluxes, and also co-benefits whenever possible. So for forest and shrublands, for example, we will also be quantifying the impacts that management will have on water and fire. The modeling will also, to the extent possible, quantify the cumulative impacts of various management actions through time. So instead of just using values from literature for individual actions to quantify the impact of management, the modeling will address the impacts that result from a portfolio of actions that occur next to and or on top of each other and at different points in time. The modeling will, of course, give us the ability to assess custom scenarios. That is to say, we can mix and match different climate, policy, and management scenarios as desired. And again, because modeling even one natural and working land type is a complex task, work is being prioritized by carbon stocks in our most recent natural and working lands inventory. As we begin thinking about which tools to use for modeling, we developed some criteria to help us determine which models to use for this work. The basic criteria are shown here on the slide. And first, any model we are going to use should be open source. We are looking for a long-term solution that we can build upon over time. In addition, our understanding of natural and working land dynamics is constantly evolving and growing, and so it's beneficial for CARB to be able to modify and grow model functionality without always needing future contracts, which take a lot of time to put into place. Additionally, because the model is open source, it will allow for others to improve or make new modules for the model without direct direction from the state. And if we cannot find an appropriate open source model, then a model should at least be publicly accessible to allow for transparency and future use and improvement over time. Second, where applicable, fire should be a dynamic process within the model. This means that within the model, fire should be responsive to management. I mean, we want to change fire regimes through management, right? So, well, here we are just saying that to the extent possible, we want a model that changes fire behavior in response to management and climate change. Third, we acknowledge that ecosystems in California are often water limited. Likewise, the physiological processes that make the carbon cycle, like photosynthesis, respiration, and decomposition, are highly dependent on water within your system. Therefore, we want a model that couples carbon and water dynamics. Ideally, a model should also include hydrology, which just means that it tracks how water moves through space, providing more water in the valleys and mountain meadows and less standing water on hill slopes or high elevation mountaintops. Fourth, climate change has led to large mortality events throughout California's forests, at least, and we want this type of mortality to be captured within our model. Climate change alone, even without any management or wildfire impacts, can have large effects on ecosystems. Additionally, we want to know what kind of management can change that outcome. And we want to capture those effects as much as possible through some kind of dynamic vegetation mortality. Fifth, the model should be scalable, meaning that the model should be able to quantify the carbon future of large landscapes. So that is to say, we cannot use models that work on the project level if that model cannot also determine what will happen to entire ecosystems given large and diverse management strategies. So for example, if we think about all of the forest models that exist, and there are a lot of them, models are designed to work on different scales. So some forest models model every single tree within a forest. And with these models, you can model very specific silvicultural practices. However, when you get to areas larger than individual forest stands, these models are no longer practical because first, we don't have information about every individual tree everywhere. Second, the computation time needed to do calculations for every tree is not practical. And we don't necessarily need that level of information for statewide analysis. A lot of science has gone into figuring out how to scale from modeling individual trees to entire global ecosystems. And we need a model that can cover at least one natural and working land type for the entire state of California. Also, the model should scale thematically, meaning that it can model impacts from climate change, disturbances, and multiple types of management. We cannot really use a model that only focuses on one type of management, for example, and doesn't include climate change impacts. Sixth, we would like a model that can model multiple natural and working land types. In the long run, it would be nice to have one model for all natural and working lands. Currently, though, to fulfill all of our other criteria, one single model cannot cover all natural and working land types. So we are looking for models that can do at least one or ideally more natural and working land types. Seventh, we also want a model to have an existing user base. This is because we want the model to still be used in science and still be improving, and where students are still graduating focused on using this model so that we can ensure the long-term future of the new CARB natural and working land modeling program. Finally, we want a model that is mature, meaning it has been around for a while and has a proven scientific track record. For some natural and working land types, we have identified a model that we're going to use. And for other natural and working land types, we're still in the process of determining what model to use. For forest and shrublands, as well as the riparian zones and meadows that lie within them, we will use the Regional Hydroecological Simulation System, or RHESIS for short, and that's what I'm going to call it moving forward, RHESIS. And with time, this model will also cover grasslands and some settlement areas. For agricultural lands, we are still trying to identify the best model for our purposes. However, we have been considering the Carbon Reduction Potential Evaluation Tool, or CARB, which is Comet Planner based, but utilizes National Agricultural Statistics Survey, survey acres of crop types to determine the acres associated with various practices. There are several limitations that are associated with both this tool and Comet Planner itself that do not fully fulfill all of our criteria. So we are still open to suggestions for the best model to use within the time frame and resource constraints we are working within. So for the rest of the natural and working land types, we are still in the process of identifying the best model to use. However, we are considering various modeling options. For example, we are looking at subcalc or national inventory models, IPCC Tier 1 methods, if you're familiar with that, or developing in-house models when no other appropriate model is available. And again, we are hoping for some help identifying the models that you would like us to use to assess your natural and working land type of interest. And please consider the time constraints under which we are working when making a model recommendation. So how this process is developed and the modeling that we will do is greatly influenced by equity and environmental justice considerations. California's natural and working lands are a critical component to healthy and resilient communities. The benefits provided by our lands contribute to public health, strong economies, and food security. However, not all communities have equal access to these benefits and also suffer from inequities such as increased concentration of environmental pollution, limited access to nature, and loss of sacred lands and species and the ability to steward them. On top of that, climate change is expected to disproportionately affect communities with the least capacity to prepare for, respond to, and recover from persistent or extreme climate events. As with any effort such as this, we must consider the implications on the people of the state, especially disadvantaged and low-income communities. Similarly, we need to work on ensuring the benefits associated with future efforts equitably shared. To this end, we will be consulting with the Environmental Justice Advisory Committee established by the board pursuant to AB 32 to advise on the development of the scoping plan. Additionally, the California Natural Resources Agency has established an advisory panel on using-based solutions to advance equity, and a summary document was released by that panel just last month. You can find it on the website linked here. And then finally, we will seek input through our scoping plan workshops and community engagement. So we've covered a lot of information already, and I would like to take a moment to review what we've covered before we enter our first Q&A session. So we have gone over so far what is included in our natural and working lands analysis, the general structure of our target making approach, along with a few definitions, the technical approach, including the synthesis and modeling, and the criteria we are using to select models and the current models we are considering. And then after this comment and question period, we will still cover our rhesus modeling for forests and shrublands in detail, the mechanisms pathways that can be used to achieve our objectives, our proposed baseline, our process for quantifying business as usual, and alternative scenarios and the information that will be used to determine a final carbon target. As I just mentioned, CARB is committed to advancing equity as part of our work, and the Environmental Justice Advisory Committee is a crucial component to advancing equity within the scoping plan. The committee members represent communities in California with the most significant exposure to air pollution and provide input to CARB on the formation of the scoping plan. And we always welcome and look forward to this perspective of the Environmental Justice Advisory Committee members in the development of the natural working land target for the scoping plan. And so I would like to first open comments and questions up at this midpoint of the presentation for our EJ Advisory Committee members first. We have listed some key questions that I will let you read at your leisure that we are presenting to everyone and hope to get some feedback on. And of course, we welcome any other comments and or questions, especially as they pertain to the topics we've already covered. And with that, I will open the floor to our Environmental Justice Advisory Committee members. So if those folks could please click the raise hand button if you'd like to speak so that we can find and unmute you. So I will pass it over to Jordan and Alex.
Thanks, Adam. Just a reminder to click the raise hand button if you'd like to give a comment. I don't see any EJ Advisory Committee members at this time. Let's give it a couple more seconds here. All right, Adam, not seeing any EJ Advisory Committee members raising their hand at this time.
All right, no problem. As I said, this is kind of an inconvenient time for some, so hopefully they'll be able to join us later on.
Would you like to move to the rest of the?
Yeah, so now, so let's open it up to everybody else. If you would like to speak, please raise your hands and please keep your comments and questions brief so everyone can talk. And right now we're trying to focus on these key questions and or things that we've covered already. We'll have time at the end for additional comments and questions if we haven't covered something already. So.
Hey, Adam and Jordan, just sorry to jump in here. It sounds like maybe there's some challenges with the raise hand function, but maybe Catherine Gruber-White would like to speak. So Jordan or Alex, if you could unmute her, that would be great.
Great. Catherine, you've been unmuted. If you click the button on your end as well, you can go ahead and give your comment. Thank you.
Hi, good afternoon, and thanks for that. What I realized after a few minutes is that there's a little kind of extra tab on the GoToWebinar control panel with the raise hand feature that doesn't always appear when you're in full screen. So I actually had to exit out of full screen to find that feature just in case anybody else is having that issue. So thank you for that. Good afternoon, everyone. My name is Catherine Garupa-White, she and they pronouns. I am the Executive Director for the Central Valley Air Quality Coalition, or CVAC for short, advocating for clean air in California's San Joaquin Valley, which is one of the most polluted air basins. Also a member of the Environmental Justice Advisory Committee and the AB 617 Steering Committee for Stockton. So really appreciate the opportunity to comment today. Wanted to offer just a few broad thoughts and observations, and then do have one question, and wanted to start by thanking the public that are participating in the workshop today and the staff who put in a lot of time to preparing this information. I really appreciated the detailed explanations, the clarity about what terms meant, trying to stay away from jargon, the acknowledgements of settler colonialism and the complicated past of California's public lands, the nod to accessibility. And so really want to appreciate and value all of that. And also still point out, as you've mentioned, staff, that this is still an inequitable process. And while we can go and share with others that can't join the meeting during the daytime, the things that we've learned, or people can watch the recordings, it's not the same thing as being able to actively be involved and ask questions. So in thinking of things like on the ground implementable actions, things like considering some evening time workshops, doing things like translation, and even little things like reminding people where the raise your hand button, as I learned today, can definitely be helpful. So wanted to acknowledge those process pieces. And then in terms of natural and working lands themselves, want to acknowledge that these are critically important efforts that the Air Resources Board and partner agencies are undertaking, and it's urgent to get it right. As somebody who teaches California geography and understands the complexity of our physical landscapes and our biodiversity, it's an enormous and complex undertaking that, I think it's important to continue to acknowledge the challenges and the limitations to the modeling and the data sources, and really appreciate the acknowledgement that this is kind of an evolving area of knowledge and exploration, and the open dialogue there. And again, we'll definitely reflect on the details that were shared today and provide some more direct response to the answers that were, or sorry, the questions that were posed. I think broadly when we're thinking about strategies like reforestation and urban greening, we hear consistently through processes like AB 617 that our communities really want more tree cover, more canopy. And again, we need to think about how we're doing this in ways that match with the complex biodiversity that already existed in California before humans started so drastically modifying the landscapes that we see in front of us today. Also want to continue to urge a push to move away from offsets. And I know that our forests have been something that we have kind of relied on for an offsetting system, and that has been hugely problematic. So that kind of leads me to the area of my question, which is I heard a lot of mention of, that this is going to need to be scalable. It's going to need to be driven by kind of local and regional actions. And when it comes to the landscapes of particularly our forested lands, roughly half of California is owned by the federal government, and more than half of our federal lands are owned by the federal government and managed by them. And I didn't really hear mention of that. And a lot of those lands are actively used for timber sales and cattle grazing. And because of our approaches to wildfire management that have not been in line with traditional ecological knowledge to date, and hopefully we're moving in that direction, but we continue to be challenged by very catastrophic wildfires on our public and working lands in California. So just wanted to close my comments with a question. It would be great if it's possible to answer it now, and if not, if we can put a pin in it and come back to it. But just some detail about how the federal government, the role of the federal government is being considered in this, how engaged they are in the conversations. I mean, I think given the complexity of our landscapes and how much is not in the control of the state and local governments, that's a really important factor. So thank you again for the opportunity to comment, and definitely look forward to continuing the dialogue at the EJAC meetings as well.
Hey, great. Yeah, thanks for the comments and the question. I'll just respond to it right now. The federal government is a huge owner of lands in California, and the state is partnering with the federal government currently in the sector to figure out how to manage these lands moving forward. So recently, the state signed a shared stewardship agreement with the U.S. Forest Service, so that we both are making plans together for treating, at least in this one agreement, they say 500,000 acres each for a total of 1 million acres per year. And we are working as a state government with the feds to figure out what that means and how best to approach that moving forward. Through the new incarnation of the Forest Management Task Force, the federal government is a partner in that, along with tribal representatives, state representatives. And so hopefully through that process, we can all come together to do exactly like you're saying, figure out how best to move California forward. So thanks. Jordan?
Great, thank you. We do have a raised hand from Martha Arguello. Martha, go ahead.
Hi, everybody. Martha Arguello with Physicians for Social Responsibility and a member of the EJAC. How are you going to incorporate the impact of pesticides on both greenhouse gas emissions, but also the impact of pesticides on carbon soil life and on the creation of stable soil carbon? And I strongly concerned about, sort of excluding the pesticides from the whole framing around the natural and working lands.
Oh, sorry. Yeah, thanks for that question. So I think we're going to pass this off to Nicole Dolney, our branch manager in the emissions inventory branch.
Thanks. So I appreciate that question. We've been doing some assessment of this, and to date are aware of 2 pesticides that we know are greenhouse gas emissions, the methyl bromide and sulfuryl fluoride. Methyl bromide being a substance that is currently being phased out under the Montreal Protocol, but there are some exceptions where it's used as a fumigant. Our assessment is emissions from this source is very small. Under the short-lived climate pollutant inventory, we track and estimate emissions from sulfuryl fluoride, and we'll be tracking those emissions there.
See if I can, there we go. Thank you, Martha, for the comments. And this is Matt Botel, the Assistant Division Chief in ISD. I just want to make a couple of additional comments too. And I want to recognize that there have been a number of comments that folks have been submitting about pesticide use and their relation to greenhouse gas emissions as part of the kickoff workshop and follow-on deep dive workshops comment logs. And so we're definitely looking at those. As Nicole mentioned, the inclusion of pesticides isn't part of the traditional AB32 inventory before those two that we're talking about here. But we are interested in looking at what those potential effects of pesticides are on greenhouse gas emissions. Right now, that's something that isn't directly included right in the modeling work that Adam is speaking to.
All right, our next question will be from Catherine Dodd. Catherine, go ahead.
Hi, this is Catherine Dodd. I'm with the Alliance of Nurses for Healthy Environments. I want to echo Martha Arguello's comments and just say that in your slides, on slide 15, you said that it was said that soil is not considered because it's too slow. Later, it was said that the Krebs cycle is slow. It is. Then in slide 17, you said you included in the carbon stocks living and dead plants, biomass, and soil. So is soil a carbon stock or isn't it a carbon stock? And then in the objectives, you used healthy soils as an example. So I'm confused about soil because eliminating pesticides from our vast agricultural land, 70% of California's acreage is agricultural or can be considered agricultural. Eliminating pesticides would greatly increase the amount of healthy soils. And I, in terms of the context of whether it's slow or not, I want to harken back to the Native American adage of 7 generations. If we had stopped using pesticides 3 generations ago, we would have much better carbon sequestration from our agricultural lands than we do today. And just because it takes a long time doesn't mean it's not important to the next generations. And then lastly, I just wanted to point out that in the meta-analysis, which many of us have done meta-analysis, so it was nice to walk through that graduate school example again. But if research on soil health and the elimination of pesticides or the use of organic soil farming, not hydroponic, but soil farming, if that isn't part of the research, it's not going to be part of the project. So I kind of feel like on the one hand, you say soil is important. On the other hand, you say soil isn't important, but you haven't found a way that I made comments on the research 2 days ago, I guess it was. So if soil isn't included in the research, it's not going to be in the meta-analysis. So I'm really confused, and I just want to echo the importance of pesticides. The other issue is that CARB, one of the goals of CARB in this scoping plan is public health. And frankly, healthy soils make healthy food, make healthy kids, and healthy soils protect farm workers. And that is the greatest EJ issue in terms of our agricultural lands, or what we're doing to farm workers. That's it. Thanks.
Yeah, thanks for those comments and questions. Yeah, sorry for the confusion. So soils are included, but maybe there's a technical kind of miscommunication. So we include organic soils. What we don't include are mineral or inorganic soils. And here to explain that a little bit more is Megan from our inventory group.
Yeah, I'm very glad that you asked this question because I had a little bit of a stumble when I was giving this presentation on this particular very niche point. So we have a wall-to-wall soil organic carbon inventory, and this is different than soil inorganic carbon. So when we're getting into it, anything that has is biologically active. So there's soil organic carbon, which is I am blanking now because of the question. 1 second. So yes, it is soil organic matter and only organic compounds. It's just a chemical definition versus inorganic carbon. So inorganic carbon changes over the course of millennia, and that's why we don't currently include it. So you have total soil carbon stocks under these two chemical definitions. We do track soil organic carbon because one, it is a really important indicator of soil health. It affects things like water holding capacity. It's a biological indicator of the health of the soil. It is fabulously important. And I love that you spoke to the 7 generations of land management. I'm a 6th generation cattle farmer. I know what that is deeply in my heart and my soul. We've managed the same piece of ground for over 100 years, my family. And that is something that we are looking at incorporating into the inventory, but I was trying to make a very specific distinction between organic and inorganic carbon. In terms of pesticides, we actually are starting a literature review on the impacts of pesticides on soil health. That is very new, and we don't have enough data to produce a quality inventory at this particular point in time. But it is not something that we think is unimportant or have couched.
Thank you.
All right, our next question will be from Karen Maki. Karen, go ahead and unmute yourself and ask your question.
Okay, so I'm wondering how you will balance the competing priorities for various forest benefits. It seems to me that increasing carbon sequestration must be the most important because we have a limited time period in order to make progress in climate change where it will really, reduce the negative impacts. If we prioritize something else, some other priority, too much, we will lose our opportunity. So we need to consider how much greenhouse gas emissions drawdown is needed to make our overall, adjustment.
Hey, yeah, thanks for that question. Yeah, this is a hard one. The natural and working lands provide a whole host of things that both communities and nature rely upon, right? So we're talking carbon, all the water, the vast majority of water that California depends on comes from natural and working lands. Also fire resilience. So how we're going to go about, after we've done this whole process that we're going to talk about, begin to sort of try to, balance these out or prioritize them in some sort of decision-making process. This is going to be a process that CARB is going to go through with stakeholders and state agency partners, and then and through also the comments from folks like you and the public comments, all taken into consideration to figure out which scenario of co-benefits and carbon do we want. So, but I guess I should just reiterate that we can't manage just for carbon on the lands, right? We have to somehow balance all of these competing resource needs across all natural working lands. So, thanks.
All right, our next question is from Tyler Madari. Tyler, go ahead and unmute yourself and ask your question.
Great, thank you. Yeah, and going back to the discussions about capturing or monitoring, the carbon sequestration potential of organic soils. I wanted to clarify: are we only relying on satellite data, because that doesn't go very far with respect to capturing the what is stored in like the deep root systems in shrublands and chaparral, for example. That requires a lot of field monitoring, and I wanted to understand if CARB has access to those databases, or if there are plans to do that work.
Yeah, soils is by far the most difficult carbon pool to measure and monitor. And so, there are soil surveys that happen through the NRCDs. And then also the Forest Service has some plots that take soil samples. Now, to be able to monitor soils going into through time, actually the methodologies that currently exist are not going and doing new soil surveys every year or every other year. I wish that was the case, but it's not. Soil surveys are extremely expensive and time consuming and destructive. That you actually have to take soil. So at how we monitor soils and how we'll measure soils in the scoping plan assessments is using ground-based inventories like what you're referring to. And so we take all of the data that exists on soil surveys, and then we use, well, we don't actually use it, but others have used satellite data to then extrapolate those soil surveys across the landscape, so we can get an estimate of what the soil is across the landscape. And now, measuring it through time and into the future is also a modeling process as well. And so our modeling that I'm going to explain coming up does take into account soils and will measure the change of soil from different management practices going into the future. So I hope that answers your question.
All right, our next question is from Julia Levin. Julia, go ahead and unmute yourself and begin.
Hi, thank you all. Really interesting presentations, and thank you for all the work that you're doing. Julia Levin with the Bioenergy Association of California. I have one question and one comment. My question is why you have never mentioned SB 1383 and the requirement by law that the state reduce anthropogenic black carbon emissions by 50% by 2030. I know there's a lot of confusion around the term wildfire, but the majority of California's large fires are only wild in terms of their behavior. They're not wild in terms of their origins. CAL FIRE determines for any significant fire what the source is. And so it's very easy to see which ones are actually anthropogenic and which ones are not to mention the whole area of prescribed fire. So I think in a natural and working lands inventory, it's going to be critical to track and to separate out what is anthropogenic black carbon from what isn't, in order to meet the requirements of state law. That is really, really critical. So I guess my question is, why isn't CARB tracking anthropogenic black carbon emissions from fire caused by human activity or human infrastructure? And then my comment is just a recommendation related to public participation. I support the comments made earlier about the need to have meetings in other locations and also at other times of day and evening. But my concern is that there are a lot of forest communities that are not represented by environmental justice groups or tribes, and that also need to be able to participate. California has a huge forest landmass, and it's really important to get input from people living in those communities, many of which are economically disadvantaged, even if they aren't heavily urbanized. So they may not meet the legal statutory definition of a disadvantaged community, but they are very much affected by wildfire and a part of the natural and working landscape. So I do hope that you will find a way to include participation from many of the state's more remote and rural forested communities as well. Thank you.
Thanks, Julia. Really Appreciate the comments and the questions. Just a couple of observations here. Clearly we are working on implementing the directive from the governor's executive order in terms of establishing a carbon target for natural working lands in support of carbon neutrality. And you referenced some important work around our 1383 targets and our need to reduce short-lived climate pollutants. And I think you can probably recall from our kickoff workshop, we also hosted a short discussion on short-lived climate pollutants and their role in tackling climate change going forward. And so we are going to have a separate process around SLCPs that is predominantly going to focus on F gases and methane. And so when it comes to black carbon, we'll have some discussion about how CARB's programs, particularly on the SLCP side, are working to address those emissions in a future workshop. I do want to flag, and you'll hear a little bit about this later on as part of the modeling work, that we are going to be looking at for natural working lands, what the potential kind of emissions associated with disturbances like fire are, but we are going to be focusing on CO2. So, I don't know if Adam, if you want to jump in any more, or if Nicole from our inventory side wants to jump in, but I just wanted to give you a little bit of framing, kind of like how these pieces are fitting together as part of the broader carbon neutrality work.
Yeah, thanks, Matt. I can add a little bit. So we know that fire has been a long part of California's landscape history, and it's part of the Earth's carbon cycle. But our current science shows that we have used that we used to have more fire than at the current level, and so we are currently tracking wildfire black carbon separately.
All right, our next question is Stephen Rosenblum. Stephen, you can unmute yourself and ask your question.
Hi, I just had a question about the graph that Adam showed about modeling projections for carbon sequestration. Is it true that we're going into a hole on that the natural and working lands are actually emitting carbon rather than acting as a sink?
Short answer is yes. Our natural and working lands inventory shows that overall, all of our natural and working lands are losing carbon stock on the landscape.
All right, our next question is from Jim Kramer. Jim, go ahead and unmute yourself and ask your question. Jim Kramer, if you can unmute yourself and go ahead and ask your question. All right, we can come back to you. Next is Craig Thomas. Craig, go ahead and unmute yourself and you can give your comment or ask your question.
Thank you. This is Craig Thomas. I'm the director of the Fire Restoration Group in California. Adam, you and I have been exchanging paper on this topic for quite a while. I just want to make a statement that we need to be really, really careful and clear how we identify fire's role in California in terms of building wildfire resilience, enhancing biodiversity, and moving us to much stronger carbon stability in the state. And so my question is, where are you getting the information and how are you establishing the natural fire regimes that exist in California today? So I'm not talking about 1800, talking about in today's world, particularly on our wildlands. How are you going to be establishing the natural fire regime, just like we have been tracking and understand precipitation in California? The other key driver of biodiversity and resilience is fire regime, and wrestling with getting our hands around the boundaries of what to generalize what good fire is versus the fire that we've been seeing on a lot of acres lately. How are you identifying where fire is beneficial? And are you talking in the Sierra Nevada, for example, low and mixed severity fire and a frequency that's been identified in research for the last 25 years? I'm hoping it's sitting at the top of your stack of papers on your desk when we go to frame what fire is in California. It needs to be as accurate as possible so that we don't fall into the trap that we've occasionally fallen in, because what we see on the news and what we see every year getting worse isn't what the system used to be. And I'm totally with you on how do let's figure out the way we're going to get back there to a more stable natural fire regime. But how are you setting those benchmarks for what the goal, what we want to get back to in terms of fire resilience?
Yeah, thanks for the question. So first I would say that we are not trying to quantify what the natural, quote unquote, natural fire regime is of California. We have a report that kind of addresses this topic that's in the governor's office right now, so it'll come out later this year. But in terms of target setting, as I kind of explained earlier in my process, what we're trying to get at first is how everybody hopes to manage the landscapes going into the future. So are we going to do more fuels reduction? If so, how much? Prescribed burning, how much? When, where? Those sorts of things. And then what we're trying to do is then quantify the impacts from those policy objectives and that change in management on the landscape. So, hopefully, our management will reduce wildfire emissions, will reduce fire severity across the landscape, and hopefully that will show up in the modeling. And then, as I'll show later on, we hope to present sort of some information about how all of these co-benefits are interacting. Some alternative scenarios may have, more carbon on the landscape, but also more fire emissions, but also less water, or, vice versa. There will be competing factors. And so in terms of wildfire specifically, and what we, quote unquote, want, we don't necessarily, we're not setting fire targets specifically. We're bringing together how all of these things, carbon, fire, and water, are interacting. And then through stakeholder processes, we're going to determine, what's the best course of action moving forward. So thanks for that.
So a quick follow-up. So on wildfire, are you, the Forest Service regularly goes in after every event and characterizes fire effects. So low, mixed, high severity, and then balance that up against what the system was or what we think stability looks like today. So are you going to, I'm worried that we don't just take the acres, the thing called wildfire, and take the acres. So we're going into a fire effects analysis, because a lot of what we see burning on the news is actually great, and some of it's horrid. And there's a big difference in any event. There's some good and there's some bad on what we see in the news stream, but nobody ever talks about it. But so I'm hoping we capture that, at least year one fire effects in an outcome, and not just use the gross acres in terms of where we want to get to. Because when you talk about, we're setting the amount of what we want to do in these different trajectories. You're getting that information then from the Forest Service and CAL FIRE in terms of the amount of burning that we are wanting to target to get to?
Yeah, we're getting as much information from as many groups as possible, federal, state, and non-government all alike. But you're right. I'm going to get to this, but yeah, it's going to be not in terms of like acres. Acres are not really our target. We're after ecological outcomes. So carbon on the landscape, fire emissions, water availability, things like that. So, all right.
All right, our next question is from Catherine Garupa-White. Catherine, go ahead and unmute yourself and begin.
Sorry, I commented earlier. I think it just may be a function of I can't tell if my hand is up or down, but I've commented already. Thank you.
Alrighty, thank you. I'll lower your hand. All right, our next question, we're going to come back to Jim Kramer, who we tried earlier. Jim, can you try unmuting yourself and asking your question?
Okay, I think I figured out how to unmute myself. Thank you very much for all of your work on this, and I really appreciate what you're trying to accomplish. But I'm curious about what the possible impact of all this will be. A previous questioner already raised the issue that half of the forests in California are owned by the federal government. You mentioned, well, you're collaborating with them, but what happens if they disagree with you? I'll just point out the previous administration prioritized timber production over climate change. So there's no guarantee that the Forest Service and you would be working towards the same goals. Another half of forests in California are privately owned. I mean, the state only owns about 3% of the forest land. In terms of the private ownership, what is your possibility for collaboration? One example, a lot of timber harvesting is monitored by the Board of Forestry. What leverage do you have if they have different priorities and their priority isn't climate change?
Let's see, there we go. Thanks for the question. I want to just touch on a couple of points on this. And so one, the focus of today's workshop is really on what is our technical approach to setting a target for national working lands to support carbon neutrality. And we do plan on having some additional discussions on what are the mechanisms. So, once we are identifying options for a target for national working lands, what are the mechanisms that will help us get to those targets or to that target? And we're going to be doing this obviously in close partnership with our state agencies that are focused on land management. So starting with the California Natural Resources Agency, and recognizing that action needs to happen kind of at the state agency level and local and regional levels. The governor, as part of that executive order I've been talking about earlier, also directed CNRA to develop a climate smart land strategy that will help to inform action on national working lands. And so, our hope here is that by working with you all to set a target that reflects the many different considerations that we're discussing, and then having some follow-on conversations about mechanisms to support action and helping to do that in coordination with the CNRA and others, we can identify what those mechanisms will be. Right now, many of the mechanisms that are supporting land management action are focused on things like state level funding and other incentives that push management action regardless of ownership of the land. So that's just a high level. There'll be more to come as we move forward on the workshop and the scoping plan itself.
All right, our next question is from Charles White. Charles, go ahead and unmute yourself. Charles White, checking to see if you can unmute yourself and ask your question.
Can you hear me?
There we go.
This is Chuck.
Yep,
Hello?
we can hear you. Thank you.
Oh, great. Thanks. This is a little confusing. I agree with some person's previous comment about a little instruction on how to use those of us that are more familiar with Zoom. I'm with Manat, Phelps, and Phillips, and I'm curious about how all of this relates to the development of bioenergy and biofuels. It's been a kind of a changing landscape. And the US EPA used to consider only fossil fuels to have carbon intensity, and biogenic fuels would have zero carbon intensity. But obviously, through the low carbon fuel standard, the CARB is taking a leadership role in determining that there are carbon consequences to various sources of materials. And I'm thinking down the road, California transitions away from fossil fuels, or maybe a demand for biofuels and bioenergy from either urban, forest, or agricultural sources. But the overall carbon reduction that would be associated with those would be highly dependent upon the source of the materials. Just an example might be if you can show that you're harvesting trees that are being grown for a fuel, that's obviously going to have some impact. But if you're taking materials from the forest that would otherwise be caught up in a fire, like down timber or thinning the forest to protect the forest, there might be actually benefits on that. So I guess the simple question is, at what point are we going to have a better understanding about how this natural working lands could affect the carbon intensity of sources of biogenic fuels, so people can make decisions on whether they want to be investing in resources to develop it.
So Charles, we're having a little difficulty hearing you. You faded out there toward what I think was maybe the end of your comment. Okay. Well, I'm not sure if Charles will be able to jump back in and finish that off, but I think the crux of your question was really, are you back? I think the crux of the question was really, how does this work relate to looking at biomass to energy and fuels? And so just at a kind of a high level, what I wanted to flag is that, as we are moving forward in setting a target for natural working lands and looking at the forest sector, and what we'll be doing is modeling various scenarios of management actions, as Adam described earlier in his presentation. And one of the outcomes of those management scenarios, and it will be potentially the amount of biomass generated through things like fuels reduction or thinning project. And so what we'll be looking to do is work on the traditional AB32 side, where we're looking at what are the energy end uses that the state has for supporting carbon neutrality, and one of those is potential bioenergy. And so using the outputs from the modeling exercise we hear to look at total biomass that is removed from the forest, how that could be converted into things like biofuels or bioenergy, what kind of considerations we should put into place when doing that as part of our energy transition. And so there is a connection here to the modeling work that we're doing, and the other work that we'll be doing on looking at the energy sector transition through our work with E3. So, look to this effort to be able to model those relative management scenarios and the potential biomass availability that could support carbon neutrality. There was another part of your question that talked about looking at kind of individual feedstock sources and the kind of carbon intensity of those individual feedstock sources. That's, I think, more of a discussion that belongs in kind of the implementation of programs like our low carbon fuel standard. This program is not going to be doing a feedstock by feedstock analysis because we're not looking at individual fuel production. We're looking at sector wide across the entire state. What is the biomass generated? What can that biomass be potentially utilized for? So I'm looking at the chat here, and I just, I feel like I need to jump in and do a quick time check. We do have more presentations ahead of us. We've got a presentation from Ryan Bart on the RESIS model, and then we've got some additional information on setting a baseline and a BAU for this. It's very important information, so I'd like to get to that. I think what we're going to do here is take one more question and then move to the next part of the presentation, and we plan to have additional opportunities for more questions after the next segment on the next presentation segment. So there's still more opportunity to comment, but this has been a good discussion. So Jordan, can you call on our last comment for this particular segment, and then we'll move on?
Yes, the last commenter for this segment will be Arohi Sharma. Go ahead, Arohi. Thank you.
Thank you. Hopefully it's a softball-ish question. Arohi Sharma with the Natural Resources Defense Council. Adam, thanks so much for this presentation and for this handy-dandy little image of where we are in the process of this presentation on the upper right-hand side of the slide, because my question has to relate to that. So at the bottom of all three of these model scenarios, there's a little box that spits out a cost number. And I just wanted to confirm with you that cost is simply one of the data points that the model will spit out, but it's not a principle or a criteria for determining which of the management portfolios to pursue for the target, correct?
Thanks for the question. So the cost will not actually come out of the modeling. The cost, and I'll explain all of this. So actually, this is a good last question. It leads into the next section. So yeah, I'll get to the mechanisms piece, which will get to the costs. And the short answer is costs actually, yeah, they will determine, it'll be information that is presented along with everything else about what it's going to take to accomplish a scenario. Maybe we can do great things, but the cost is just untenable. Who knows? So costs are a part of the information that can be considered. Okay, let's move on. Thanks for all of the questions and your guys' engagement. That was great. Really appreciate all that input. So now let's take a closer look at rhesus, which is the model that we're using for forest and shrublands. And as I said, this natural and working land type consists of 85% of all California natural and working land carbon. And so this model will assess the vast majority of statewide carbon. And to that end, I would like to introduce Dr. Brian Bart with UC Merced, who will dive deeper into the rhesus modeling. And Dr. Bart is our expert on rhesus modeling and is an assistant project scientist in the Sierra Nevada Research Institute at UC Merced, where his research examines the linkages and feedbacks between hydrology, vegetation, and disturbances, with a focus on how linkages vary under different climate regimes and management practices. Dr. Bart has a BS in genetics from UC Davis, an MS in geography from San Diego State University, and a PhD in geography from a joint program between San Diego State and UC Santa Barbara. So, Brian, the floor is.
Thank you for that introduction, Adam. I want to begin this portion of the talk by emphasizing that a key reason we are implementing a new modeling approach is because climate change is here. Over the last decade, we have experienced wildfires that are more severe than previously observed. The figure on the left shows CO2 emissions associated with wildfire over the last 2 decades, including last year's unprecedented CO2 emissions. Drought has also returned to California, as shown in the right figure. The scientific literature has shown that drought severity can be exacerbated by climate change. And we have witnessed climate change effects on vegetation throughout the state, including greater forest mortality and shifts in species compositions. Essentially, we have entered an era with conditions that have no precedent. Consequently, we can't rely on predictions about how the future is going to be. We are dealing with novel conditions. Thus, our modeling framework needs to match our need to understand how novel conditions are going to affect carbon. That said, the story is not just about carbon, as carbon is intricately linked to water and fire. As can be seen in this figure, carbon on the landscape, particularly in the form of vegetation, both affects and is affected by water and fire. And this is somewhat intuitive, as water availability controls vegetation productivity. And at the same time, the amount of vegetation on the landscape affects soil water incorporation. For fire, vegetation and dead fuels on a landscape are one of the primary controls on how easily fire spreads, while the amount of vegetation on a landscape is partly controlled by the time since the most recent fire. These feedbacks between carbon, water, and fire mean that when there are changes to one component of our ecological system, the others are likely to be affected. Thus, we must integrate carbon, water, and fire into one modeling framework in order to better understand the impacts of climate change and management actions. And this is not simple. However, this is not simple, as this integration will vary depending on the scale, location, and time period we are looking at. For example, interactions between carbon, water, and fire will differ along the North Coast redwoods compared to the Sierra Nevada forests or San Diego shrublands. Modeling that integrates carbon, water, and fire has not previously been conducted at a statewide, but that is what we are setting out to do with this project. And for this, we'll be using a model called rhesus. The Regional Hydrologic and Ecological Simulation, or rhesus, is a process-based watershed scale model that fully integrates feedbacks between carbon, water, temperature, precipitation, fire, soil nutrients, mortality, and management. This makes rhesus a powerful model for understanding the complexities of our natural lands. rhesus is a well-established model, having been around for almost 30 years, with the first iteration of the model published in 1993 and the current model version developed about 2 decades ago. In that time, over 100 scientific papers have been published using RHESIS to explore ecohydrologic related questions. Being a process-based model, RHESIS can simulate novel conditions that have not occurred before, meaning that this model simulates biological and physiological processes like photosynthesis, respiration, decomposition, and mortality in response to external factors like climate. In this way, RHESIS can simulate the impacts of climate change on an ecosystem, even if we have not experienced that type of climate in the data record. This is one of the key necessities for this modeling project that we are conducting. We can introduce downscaled climate change scenarios or introduce different types of land management into the model. Another key feature of RHESIS is that it doesn't just simulate carbon, but hydrology and fire as well. Thus, we can have a model that grows vegetation according to incoming radiation, temperature, day length, precipitation, and humidity, as shown in this diagram. But the vegetation is also affected by water availability and fire severity. This will provide us with better estimates of carbon dynamics into the future. An additional benefit of modeling the interactions between carbon, water, and fire is that not only do we get a better estimate of carbon, but we can also pull out of the model estimates of future water availability and fire risk as well. Output of these co-benefits will be used to help guide targets that don't just maximize carbon, but rather analyzes all three. Within RHESIS, the movement of water is represented at the hill slope and watershed scale. This allows us to capture dynamics that are not featured in many larger scale carbon models. If we imagine for a minute that this figure represents a hill slope in the model, we would see the snowpack is dynamic and affected by climate and vegetation. Water flows downhill so that vegetation on the landscape has different access to water depending on the site location, with riparian areas generally having more water than the hilltops, as we would expect in real life. There are also feedbacks between vegetation and water, which ultimately affects how much water moves to the rivers and water supplies, and how much water is available to support growth of vegetation on the landscape. Fire is dynamically incorporated into RHESIS, also such that the fire model affects and is affected by vegetation, water, and management action within the model projections. Fire starts and spread in response to vegetation. The fire starts and spreads in response to vegetation, management, wind, and topography. And further, this fire spread is spatially explicit, such that fires within the model are self-limiting. Fire effects are incorporated via, we incorporate ladder fuels into the model, which allows us to incorporate management scenarios into the model. And finally, I'll note that the fires in the model are not designed to replicate historical fires with exact historical boundaries, but instead represent potential fires that could happen in a landscape. Next slide. Of course, no modeling framework is perfect and can capture everything, and RHESIS is no different. The important thing is that we recognize these limitations and try to understand their potential effects on the model findings. Because RHESIS models many processes, it is inherently a complex model that requires resources to parameterize and run, which necessitates time, computation, and technical resources and skill of the modeler. We will be using supercomputers at both UC Merced and CARB to do this modeling. And there are also limitations on what RHESIS can and can't do. For example, there's no mechanism in the model for vegetation type conversion at this time. So results that we get must be analyzed with that understanding. And there's also limitations on how we represent silvicultural treatments within the model. But no model can represent all processes, but we feel that RHESIS captures the key processes that will allow CARB to make informed decisions about California's natural lands. And finally, I want to note that RHESIS is a fully open source model, a limitation of the model, as it says in the title there, but rather a substantial benefit. Model code is available to everyone at the link provided. Now that I've introduced the model that we'll be using, I'll now transition to how we'll be conducting the modeling project. Down the line, there is an intent to conduct RESIS modeling in all watersheds throughout the state. However, for the 2022 scoping plan, we'll be dividing all natural lands in California into 12 ecological units, or eco units, and in a representative watershed within each ecological unit. The objective of this grouping is to cluster watersheds that are sufficiently similar so that we can simplify our modeling by reducing the absolute area that we have to model. In the figure, you can see the data that was used to determine the ecological units on the left-hand side. They include vegetation cover that comes from land fire, aridity that is defined as the 30-year average of climatic water deficit, and Bailey's ecoregions. On the right side, you can see the resulting eco units, with each color represented a different eco unit. The fractal lines are the watersheds of California, HUC 12s if you're familiar with hydrological units. We'll be conducting our modeling at this watershed scale. The watersheds that have the yellow outline and black interior are potential representative watersheds for each eco unit. We've identified these watersheds as having sufficient data to accurately parameterize our model for each eco unit. We'll be parameterizing RESIS to each representative watershed using the flow chart shown in this slide. Parameterization case means to ensure that the model is functioning correctly and for each watershed and vegetation type. Now, I'm not going to get into the details of this approach, but I do want to highlight a few points. First, I want to emphasize that we will be using a robust multi-step approach to parameterizing RESIS, involving the parameterization of vegetation, then hydrology, and then fire. Second, for each step in this parameterization, we'll be comparing the model to outside data resource or outside sources. For vegetation, this will involve comparing modeled vegetation to CARB inventory metrics, gross primary productivity from eddy covariance towers where available, and MODIS net primary productivity. For streamflow, we'll be comparing modeled streamflow to observed streamflow, and for fire, we'll be evaluating the model with land fire products. This parameterization scheme is meant to ensure that RESIS is functioning correctly and can be applied to novel climate and management simulations. Once RESIS is calibrated to the representative watershed in each ecological unit, we'll be simulating multiple management strategies that will be designed to fulfill the policy objectives of a certain scenario. Listed here, we have some hypothetical management strategies as examples. The first two management strategies, no management without natural disturbance and no management with natural disturbance, are meant to bookend, to provide bookends for wildfire, with one strategy simulating the watershed behavior without fire and the other with a natural fire regime without suppression. The business as usual strategy represents keeping management on the landscape from the last 20 years constant all through the future. Details of the development of the BAU strategy will be provided later in this workshop. The aggressive management and realistic management strategies are meant to provide plausible outcomes based on policy changes. The climate scenarios we will use were generated using the LOCA climate downscaling technique for the fourth California climate assessment and are freely available on the CalAdapt website. This assessment, the fourth assessment has identified 4 priority climate models that represent the range of climate models that exist, and we will use these for our modeling. The climate data that we get from each climate model will consist of 3 data sets: historical climate data set, a representative concentration pathway, or RCP 4.5 emission scenario, and this is essentially the optimistic view of the future where emissions decrease. And then we'll also be running a RCP 8.5 emission scenario, which is essentially our current trajectory. As I mentioned, we'll be modeling representative watersheds, but we still want to model the diverse ways in which California's forests and shrublands are managed, even within the same eco unit. So to capture the diverse management across the state, we are quantifying how watersheds are managed within eco units based on who is the dominant owner of the water, who within the watershed the dominant owner is. The ownership groups we are using include the forest industry, cities, counties, federal lands, nonprofits, special districts, which includes land managed by local governments for specific services like water districts or community services districts. Then we'll also be, then there's state land, and then reservations and rancherias. We are then quantifying how each of these ownership groups manage watersheds in each eco unit using historical treatment information seen on the right. Adam will talk about this process in upcoming slides. We'll then be able to model our representative watersheds as if they were managed by each ownership group in an eco unit, and then simulate changes to these management strategies as needed to meet the policy objectives you all identify. Once the representative watershed is simulated in different ways for each ownership type, we'll then upscale the results to the eco unit by multiplying the ecological outputs by the area that the ownership group represents. In this way, we can upscale our watershed results to the eco unit level. So for this scoping plan update, the results of our modeling will be spatially explicit to the eco unit scale. Additionally, by simulating treatment strategies within our representative watershed in this way, we can easily mix and match watershed level management strategies across an eco unit, and that we need to fulfill the regional policy objectives of a scoping plan scenario. Now, modeling forests and shrublands across California presents a few special challenges. First, every region is different and has different environmental conditions and ecological dynamics. This presents a challenge for modelers because it means that it's hard to simplify the amount of work that needs to be done by reducing the actual area that needs to be modeled. If California's forests and shrublands were all very similar, then parameter modeling would be much easier. Second, climate change is projected to affect different areas of California in various ways. Some areas are projected to get wetter, while some other areas are possibly going to get drier. All areas, however, are projected to get hotter. This diversity in climate change impacts, again, limits the amount of simplification that can happen. Third, there is a large body of literature about how specific actions will impact carbon, in forests especially. Less well known is how lots of varied actions combined will influence carbon across large areas and over long time scales. This indeed is a major reason for this modeling. It also means that there are not a lot of studies against which we can validate our results. And finally, fourth, and this is more of a practical problem than a scientific one, is translating policy objectives to management strategies. That is to say, if a policy objective is given in very abstract terms like improve forest health, it is very hard to figure out what that actually means for changes in management across California's various regions and ownerships. For this reason, Adam's has been asking for as specific policy objectives as possible so that we can accurately model how you all envision the future of forest and shrubland management throughout California. In the end, we will have to translate your vision to daily on-the-ground management for modeling purposes. And with that, I will hand the controls back over to Adam. So thank you very much.
Awesome. Great work, Ryan. All right, so the outcome of Ryan's modeling and the modeling we will do for other natural working lands types will quantify the ecological outcomes of management and climate change. Modeling and analysis are only as good as the mechanisms put into place to achieve the actions modeled within the scenarios. And those mechanisms are highly dependent on local and regional priorities, objectives, capacity, and support for implementing them. We began to dive into what these mechanisms might look like last year at our Natural and Working Lands Carbon Neutrality Workshop, if any of you saw that. We heard lots of innovative ideas regarding various levers and mechanisms that could be used to increase the pace and scale of the actions needed. Carbon mitigation banking, for example, procurement, policies, ecosystem service valuation, certification programs, among many others. And CARB staff have been working to understand many of these mechanisms, which will be addressed in later workshops focused on the key opportunities, barriers, and solutions to accelerating nature-based climate actions. Some of these mechanisms include those shown on this slide, but there are also many other mechanisms that are not on this slide. We recognize that. Once we have determined the policy objectives at various scales, modeled the management strategies needed to fulfill those objectives, and then through the modeling quantified the ecological outcomes, the mechanisms pathways step, as promised, I got to it, in this whole process will identify all of those policies that will be needed to elicit the change in on-the-ground action as identified by the policy objectives. So for each alternative natural and working land scenario that is tenable and desirable, this step will create a mechanisms pathway that will achieve the desired action. So through this exercise, we can then begin to quantify the cost associated with the various scenarios, natural and working lands alternative scenarios that we will assess. Okay, we'll now talk about all of the, we've now talked about all of the individual steps to the scenario development process. And now I want to talk about how we will assess the effectiveness of natural and working lands alternative scenarios. There are two different metrics against which effectiveness will be assessed, the most important of which is the baseline. But we will also, in general terms, assess effectiveness against one specific future scenario, that is the business as usual scenario. And often these two things, the baseline and the business as usual scenario, are conflated and sometimes a little bit confused. However, these terms refer to two very different components of target making. A baseline is a quantifiable carbon stock or sequestration rate at some moment in the past that will be used to measure progress towards a future carbon target. So for example, in the previous scoping plan, fossil emissions have a target of 40% below 1990 emissions levels by 2030. In this example, 1990 emissions are the baseline off of which a target is defined. Business as usual, on the other hand, refers to a specific scenario of the future where no changes to land management occur compared to your baseline time period. So essentially, it's quantifying the outcome of no action. All that being said, I would like to present a recommendation for how CARB would like to define a baseline off of which natural and working lands targets will be assessed. So a baseline will, for natural and working lands, will have two parts. Carbon stocks during a particular year, carbon stocks being the amount of carbon that's actually on the landscape, and carbon stock change between 2 years. So we would like to use carbon stocks in the year 2014 and the carbon stock changes from 2001 to 2014 as a baseline time period. The reason why we are recommending this time period is because it is during this time where we have the best management and ecosystem carbon data statewide available to us. Now on to business as usual scenario. And the business as usual scenario would ideally reflect the management that existed during the baseline. And then that management would not change as we experience climate change to assess the ecological cost of no action. So to that end, we are quantifying business as usual to match the management between 2001 to 2014. That is to say, we are trying to quantify how we, as a state, managed all of our natural and working lands during this time period. To do this for our BAU time period, we need to use all of the data available to us to answer a few questions. First, we need to know who is doing the management in terms of general ownerships, like the federal government, state, local governments, NGOs, forest industry, tribes, small private landowners, just to name a few. We need to know where are treatments happening, because management is not uniform across the state. What type of actions are happening, like thinning, prescribed burning, etc. How big are treatments when they occur? How frequent are treatments happening? And annually, for each ownership type and natural and working land type, how much land in total is experiencing a specific treatment type. Again, this exercise will be used to assess how no climate action under climate change will impact the environment and ecosystem services. We have already done some work to quantify business as usual for forests and shrublands. So for this natural and working land type, or types actually, it's two, we have statewide annual maps for treatments and disturbances from 2001 to 2016. However, from 2014 on, there are known problems, so we are using the data from 2001 to 2013. And this data comes from land fire, which is, again, a national product put out by the Forest Service in collaboration with the Nature Conservancy. And the reason we are using this particular data set is because it includes all ownership types. It has harmonized treatments across individual data sets that report activity, and it's wall-to-wall, meaning we have data across the whole entire state. On the right-hand side here, you will see the proportion of treatments and disturbances that affect the land. I think Megan showed this earlier. You can see that the acres treated by management are actually much lower than those acres affected by wildfire. And this comes, yeah, again, this image is from the Natural and Working Lands inventory. And so I'd like to walk us through an example of how we are quantifying a business as usual scenario for forests and shrublands. And so as Ryan showed, we have split these natural and working land types into 12 eco units. And the humid Sierra is one of these units, and it's designated here in this map by the yellow area. And for each eco unit, we are using the data from land fire to answer 3 questions. For each dominant ownership of a watershed within this eco unit, and by the different management action types, how many acres get treated annually? How often do treatments occur, and how big are the treatments when they occur? Then we get a bunch of statistics from that exercise. And using the statistics, those statistics, we have developed a model that turns those statistics into daily management for our representative watersheds. And as Ryan explained, we will be modeling representative watersheds of each eco unit, right? So we're going to model these watersheds as if they've been managed by different ownership types. So for example, Sage Hen is the representative watershed we are using for the humid Sierra. And you can see it here in this map by Lake Tahoe. And the reason why we're using SageHen is because it has a tremendous amount of data that allows for more accurate modeling. And shown in this zoomed in map of SageHen, you can see the streams and the areas that are too steep for treatments. And so when we're doing this, we're trying to take into account common forestry practices and California's forest practice rules. And the slope of a forest can dictate whether a treatment can happen in a specific area or not. We also show the streams because riparian zones can be managed differently than other locations within the watershed. And our management model that we've developed takes these things into consideration. SageHen is a federally owned watershed in reality. And though its management is a little mixed because the University of California system plays a role in managing this watershed. But anyways, we generate daily management maps for this watershed, in this example I'm showing at least, as if it were managed by the federal government. And all of this management that I'm showing here in this map, it's all modeled from our BAU statistics. And in this example, a thinning occurred on October 4th, 1904, with various thinnings occurring throughout the watershed that year. Then if you look at all the treatments throughout the watershed from 1900 to 1950, you can see a spatial distribution of the management. And we will produce this type of information from 1850 to 2100. And that information is required as inputs for our modeling. And the reason why we're running the model from 1850 forward is because we have to produce conditions in 2014, our baseline year, that represents what this watershed would look like had it been managed by each of our ownership groups. In this way, we can create initial conditions for our modeling that are representative of all watersheds within an ownership. We will do this for all ownership groups in an eco unit, as well as run a no management scenario to assess the impact of Euro-American westward expansion and the subsequent management that followed. This particular scenario will attempt to quantify the past, present, and future carbon, water, and fire that would occur under present and projected climate if no Euro-American intervention had ever taken place. Then, ecological outcomes of this watershed level modeling under the different ownership types will get scaled up to the eco unit level and then aggregated to the statewide scale. Again, these outputs will be annual from 1850 to 2100 and will include information on carbon, water, and fire dynamics, and this does include soil. The business as usual scenario is an extremely important scenario to model to demonstrate the results of inaction. However, when developing a carbon target, the real goal is to assess the greatest impact we can realistically make to fight and adapt to climate change. To accomplish this, this is where the scenario development process that we explained comes in. An alternative natural and working lands scenario will have a unique combination of 4 components: statewide and regional objectives, a suite of regional management strategies that meet those objectives, a mechanisms pathway portfolio to pay for the change in management strategies, and then of course the ecological outcomes and costs. The ecological and economic outcomes of a scenario are determined by state, regional, and local governments and communities' aspirations for how they would like their lands managed and how they would want to change or how they would want that change in management funded. Therefore, the amount to which natural and working lands will contribute to fighting climate change will depend on how far each of you are willing to push your industry, community, and policymakers in that direction. CARB is not predetermining a carbon target. CARB, again, is not a land management agency, but we are the state's climate change planning agency. And additionally, we are not tasked with regulating any one natural and working land type or industry. And so we are wanting to act as objective planners and scientists that can aggregate and quantify what we hear across all natural and working land sectors and bring it together into a coherent statewide strategy. Additionally, CARB is not finding the optimal scenario to maximize ecosystem services across the state. This would require a process that is often unrealistic and could result in unrealistic expectations. Not to mention that the computational resources needed for such an exercise are not accessible to CARB staff. So in the end, when we get to the target development process, we are hoping to deliver something that looks like this, but with specific numbers, where we have multiple alternative natural and working land scenarios as shown across the top. And for each scenario, we provide a suite of ecological and cost outcomes associated with that particular scenario, along with a narrative of the objectives, management strategies, and mechanism pathway that resulted in these ecological and cost outcomes. And in this table, the arrows and circles show either an increase or a decrease or no change as compared to baseline values. And as you can see, we fully expect that there will be trade-offs between carbon and other ecosystem services as well as costs. And CARB will work with stakeholders to identify which of these scenarios is the one that will ultimately result in the natural and working lands carbon target. Finally, we have arrived at the final step of the target development process. The carbon target date is the end of 2045. Like the baseline, the carbon target will have two components: a carbon stock change as measured from our baseline, and a carbon sequestration rate based on a moving average around 2045. And again, we are using a bottom-up approach where the possible carbon targets are determined by local and regional objectives. Stakeholder input on the desired scenario will help inform staff's proposal to the board, the Air Resources Board's board, on the carbon target. The CARB board will consider the natural and working land target as one component of the overall 2022 scoping plan. The carbon target will be based on the outcomes of the alternative scenarios that I just spent time describing, the synthesis that Alex explained earlier, and all of your comments and general engagement. The carbon target provides a metric against which governments and organizations can measure progress and to which they can be held accountable. The scoping plan as a whole will serve as an actionable blueprint for state and local agencies to use to address climate change. And as I described at the beginning of the workshop, CARB has been involved in nature-based climate solutions for several years, and we already have some ideas about what some of you would like to see and or not see in our work, as well as various environmental justice issues that we must address. Okay, so here we're gonna enter into the next Q&A session after this, but let's take a 5-minute break. And so let's see, I have 3:45, so let's be back at 3:50. Okay, it's been 5 minutes, so we are going to move on. So welcome back. We would now like to open it up for the most important part of the workshop, the public comment, question, and discussion period. And I've listed a few more key questions just to get the discussion moving and let you know that we really want answers to these questions. And note that we acknowledge that many of you will want to recommend various mechanisms, whether that be increased funding for incentives or deregulation of this or that. Now, when you recommend something like this, please include how you think that will affect on-the-ground action. We are not asking this to dissuade you from making a suggestion. We are asking because eventually we need to determine what mechanisms will elicit the change in management that will fulfill our desired objectives. And to do that, we need to know what the expected behavior change will be from your proposed mechanism. Additionally, if you need more time or would like to put your thoughts into writing, we have an open docket that you can find at our scoping plan website. And that docket will be open through August 3rd. So again, as you recall, we also have these key questions from earlier. And we still want those to also be addressed. But for now, I will leave these questions up. And so I'd like to first, again, open the comments and questions to our Environmental Justice Advisory Committee members. So if the committee members would please click to raise their hands if they would like to speak so that we can find and unmute you, that would be great.
All right, we have a raised hand from Martha Arguello. Martha, go ahead.
Yes. Well, I'm going to follow some of the directions, but not all of them. What's missing? I am sort of deeply concerned that as you discuss all of these issues around this intersection between water and soil and energy, that we're not talking about, and fire, we're not talking about sort of how toxic current fires are, particularly if they're in suburban areas or other inhabited areas, as homes burn or industries burn or businesses burn, and those releases and how that, I don't know what the interplay is, but it feels like to not discuss it and bring it up is matters. And then, you know, again, the other issues are around, you know, their process and engagement. And to get meaningful engagement, you also have to do meaningful education of communities so that they understand the issues. And, you know, this process does not lend itself to that kind of meaningful participation, especially, you know, when you're talking about complex modeling and other tools. That is of deep concern. And second, you know, we've not had a lot of participation from tribes and indigenous communities in the scoping plan. And so I think you're going, you know, in all of the areas that on the natural working lands, I think in particular, you're going to have to do extra outreach and more effective outreach to make sure that we are incorporating indigenous voices from, you know, from both tribes, but also, you know, LA has one of the largest populations of indigenous people in the area. We don't often have a way of engaging them. So I think we need to do a lot more work in that area.
Great. Yeah, thank you for the comments. To your first point about fires and the effect of fires on human health, that is something that we are going to address. So we're first quantifying the emissions associated with the fires in the modeling that Ryan was talking about, and then trying to assess the human health impact from those emissions. So that is happening. I will also say that there are some challenges associated with getting, I think what you're referring to is like the toxic fires. As fires burn through homes and communities, you know, CARB is trying its best to try to estimate the emissions from those sorts of fires. And so we're currently, you know, we're working on that process. And then engagement with communities, I agree wholeheartedly. So, you know, we're hoping for you all, both the Environmental Justice Advisory Committee and then everyone else here, to please let everybody that you know about this work and this process, and please connect them to us, whether, you know, it's through the open docket now or other public processes. Agree 100%. And then tribal engagement. Yeah, so we are conducting outreach with tribal governments, and this is an ongoing process. Us as a state also, we're working on improving our tribal government outreach. Again, I would point to our new incarnation of the Forest Management Task Force, for example, just as an example, who has tribal representatives on the executive leadership of that task force. So yeah, thank you for the comment.
All right, looking for any more raised hands from the EJ Advisory Committee. If you're on that committee and you'd like to ask a question, please raise your hand now. All right, Adam, I'm not seeing any at this time. Should we open it up to everyone else?
Yeah, so let's open it up to everyone else. Again, click the raise your hand button, and please keep your questions or comments brief so that everyone can speak. All right, yeah, let's go.
All right, the first question is from Dan Silver. Dan, go ahead.
Good afternoon, Dan Silver, Endangered Habitats League. Down here in Southern California and also on the Central Coast, there's a lot of shrublands. The threat that's missing is the threat of conversion from natural habitat to a developed landscape. And in that sense, the mechanism that should be considered is land protection, which is a fee title acquisition. Conservation easements are not particularly relevant. But in the materials to date, there's just a tremendous emphasis on management, which is particularly relevant for forest systems, but really not for the shrublands, unless you mean management in terms of actual restoration of native species. But treatments per se are not relevant to shrublands. So my comment is, let's talk about the threat of just land conversion and then the mechanism of land protection, which does mean money, which is something that nobody seems to want to talk about much, but I'll raise the subject. Thank you very much.
Yeah, thanks. Thanks for that comment. Yeah, so I guess there are kind of two issues here in your question. So land conversion, just like you kind of pointed out, could mean switching, say, from like forest to shrublands or something after a wildfire, and then where they just remain shrublands. And that type of land conversion is going to be covered in our modeling. And then there's what I think actually you're referring to more is land use change. And so for certain natural and working lands types, land use change will for sure be included. And as I said, we're still developing our modeling framework for a bunch of different natural working lands types. And if land use change is a primary driver of change in that type, then of course we need to include it as we go forward. But then, assessing the effect of land use change is kind of hard, right? Because in terms of a mechanism, traditionally, it's calculated sort of as an avoided emission, where you have your protection, and then you kind of simulate what's happened if that protection didn't occur. And then you have your benefit, which is the delta of that. And as we said, avoided emissions are not really considered in this. We're tracking the carbon stock change through time. And it could be that, preserving lands as they are, and it probably is the case, that preserving lands as they are will have increased carbon stock through time. And that should show up in our modeling, actually, right? So we won't assess the avoided emissions at the beginning, but we should be able to track the carbon stock change through time.
Great. Our next question is from Lori Wayburn. Lori, go ahead and unmute yourself and you can ask your question.
Thank you. First, I just want to thank you all very much for a very extensive and thoughtful presentation, a huge amount of work. I have a couple of questions here, and one is that if I understood RESIS correctly, it does not capture changes in forest management, i.e. silviculture well. With 85% of the state's carbon stocks in forests and trying to model out changes in how we manage it, that would seem to be a bit of a lack, and I'm wondering how you plan to compensate for that. Secondly, within the 12 ecoregions of the state, there's very high variability in the productivity of these areas. And so I'm wondering how that is going to be taken into account. Thirdly, I appreciate your optimism about RCP 4.5 versus 8.5, but since we're already exceeding 8.5, which is a rather frightening scenario, but it is more real, could you explain how you're going to discuss the likelihood of the 8.5 scenario coming to pass? And why don't I stop there? I have a bunch of other questions on comparing the long and short term, with the exception of going back to Craig Thomas's point about the issue of the impact of fire as opposed to the acres of fire. And I've just heard some potentially confusing things from you all as to looking at acres versus looking at impact. And particularly as we're looking to expand the use of traditional ecological knowledge and cultural fire, prescribed fire on the landscape. And there was not much of that in the time period looked at for the business as usual, but we're looking at that going forward. How does that play into this issue of not counting avoided emissions if we're looking to the use of that tool to reduce the catastrophic fire impacts that we're seeing today? So why don't I stop there?
Great, yeah, thanks for the question. So your first question had to do with management and silviculture and how that's captured in the model. And so, so when I say RESIS can't capture specific silvicultural treatments, you can't go in and say, you can't like selectively harvest specific trees from the landscape because we're not modeling individual trees. However, it doesn't mean that we can't model management, and we are modeling management. So we will have sort of treatment classes or categories. So this would include things like prescribed burning, thinning, harvesting, clear cutting, mechanical treatments, and mastication. I think those are the categories, and those are actually defined in land fire. And so that's what we're using, because that's what we have information on, and that can be modeled. So and then in terms of the variability within ecological units. Yeah, so and you specifically mentioned productivity. So the whole exercise of doing the ecological units was to cluster as best as humanly possible watersheds that are very similar in environmental conditions. And yes, of course, there's still variability within those ecological units. However, this is a simplification or an assumption that had to be made so that we can attempt to cover the whole state with our modeling. And as Ryan mentioned, our ultimate goal is that in time, we're actually modeling every single watershed in the state. That's where we want to get to. But given our time constraints now, this was the best way we thought we could get to a statewide estimate from our modeling in a scientifically defensible way. Is it perfect? No, but it's still a viable way to represent the rest of this, the whole state. And then you asked about RCP 8.5 and that we're actually on a worse trajectory than RCP 8.5. Okay, so here we're limited to the data that is available to us. And the data that is available to us is the climate data from the fourth California climate assessment. The CEC has funded new climate downscaling from any new GCM outputs that will come in. And so when those are available, we'll switch and we'll use those. But those are not going to be available for this scoping plan. And then you asked about acres versus impact. And so as I was showing, in the end, what we're presenting is the impact, the carbon impact, the water impact, the fire impact. And that's what we're making decisions on. The costs will be directly related to the amount of acres that are treated. So that's also another factor to consider. So acres treated will affect costs, but that's only one consideration of the many considerations we're hoping to present when it comes to decision making. So thanks for your comment. And you can always provide even more. You said you had a lot of questions, so please put those in the written docket, please. Thanks.
All right, our next question is from Shay Wolf. Shay, go ahead.
Hi, thanks once again for this presentation. And I had a few mostly process-related questions, and I'll submit some more detailed written feedback. But the first is on just the meta analysis, the two meta-analyses that you're doing, and just transparency and public comment opportunities around those, around the studies that you included and considered. And just, a flag for me was, one of the premises that you started with the presentation are that natural working lands are a net source of carbon, but in the forest carbon plan that CARB participated in, it looked at Forest Service, FIA data through 2015, and at least concluded that California forests are still a strong net sink of carbon. So just wanting to get understanding about the kind of transparency around the meta-analysis process. A second question is related, and that's around just transparency around the RESIS model and just the assumptions that go into it around the silvicultural treatments and wildfire emissions. A lot of those things, can be very tricky. So transparency around those modeling assumptions. The third point was just on policy objectives that we'd like to see included, and this harkens back to some prior comments of land conservation, and that includes forests. There's a literature on kind of logging for wildfire reduction risk actually releasing more carbon than would have been released if those that had been burned in a fire, and big literature around proforestation or letting forests grow intact for both climate and climate resilience benefits. And similarly, a policy objective for agricultural lands would be as a focus on composting agricultural materials, no pesticides, all those things that really support healthy soils and communities. And just one final point would just be echoing some of the comments on community engagement. This is a very technical process with technical modeling, and I think you're really going to have to do a lot of outreach to different communities and tribes on this process. Make sure that it's a very inclusive process because it is very technical, and I don't know that you have enough access points for folks, both in terms of when the workshops are held and other ways for folks to participate. So thank you.
Yeah, awesome. Thanks for your comments. Okay, so the first question was about the meta-analyses and public process and transparency associated with that. So first, I'd like to encourage you to submit, and everybody else, to submit all the studies that you would like to have included, or just, to ensure that they are included, put it into the public docket, and we will include them. And then transparency, yeah, with the scoping plan process, reports will be coming out where we'll be reporting when we have, actually, results to share. Second piece was about the source versus the sink. And yeah, so, the CARB, natural and working lands carbon inventory, is all lands. Okay, it's not just forests, it's all natural and working lands. And the Board of Forestry inventory is just forests. And additionally, you are correct, they do show that remaining forests are a net sink. And that's true, right? Remaining forests are a net sink. However, when you take into consideration the land conversion associated with wildfires and forests turning to shrublands or grasslands or what have you, then that's how you get to natural and working lands being a net source. Modeling assumptions, again, yes, we're going to provide all of our assumptions in reports and through the process as we move forward. The policy objectives in terms of forest conservation. Yeah, okay, duly noted. And composting, yes, thank you for the input. And then community engagement. Yeah, again, we agree. And so we're looking to all of you who are the engaged public to please help us get the word out. And we're doing the best we can to engage with communities. So again, please provide all of your comments in the written docket so we can make sure that we include everything that you just said. So thanks.
All right, our next question is from Lauren Miller. Lauren, go ahead and unmute yourself and you can begin.
Okay, I'm working on it. Can you hear me?
Yes, we can. Thanks.
Okay, thank you. I wanted to go back all the way to, I think it was Dan Silver's comment, if I'm getting the name right. But as a land trust, I too am obviously interested in land protection. And we see conversion as one of the greatest threats to land's ability to store carbon. So I just wanted to emphasize that. And living in our region is Fresno, Madera, Mariposa, and Merced, mostly the eastern side of all of those counties. And we see great threat to we don't conserve farmland, but that's another threat, is threat of farmland conversion to housing or other uses that are not as applicable to storing carbon. And then a lot of our grassland and rangeland, the majority of the area that we're working in we're doing conservation easements and or fee title protection of properties that are grazed grassland, mixed shrubland, chaparral, blue oak woodland, conifer oak woodland transition. And I think, one of the things that we really enjoy is we would like to we are doing active management, and our landowners are actively involved with SFC, NRCS, Natural Resources Conservation Service, some of them in the Healthy Soil programs, working on, activities that will help store carbon and, provide other ecosystem services that can address climate change. And those are all great actions, but they're particularly great because they're occurring on properties that are no longer under threat of conversion. So just a thought, when we're investing in land management, to consider the long-term protection of the property, if that can be, in a voluntary way, of course, when you're working with a private landowner, but just thinking about, the investments that the state makes in programs and things like that for land management, how permanent are they to carbon storage and or climate change if the land can be converted the next day into a use that eliminates those practices. So thank you.
Yeah, great. Thanks for the comments. I would encourage you to also provide those in writing in our public docket.
Happy to, sure.
Thank you. Okay, next.
All right, next we have Kelly McCoon. Kelly, go ahead and unmute yourself. There we go.
Yeah, this is Kelly McCoon with Sustainable Conservation. I was thinking of this last bullet point and just thinking about some mechanisms, especially from other state agency kind of regulatory action. So just one thought is for irrigated agriculture, and the implementation of the Irrigated Lands Regulatory Program, regional water quality control boards are starting to recognize soil health practices like cover cropping and compost for their role in, scavenging or tying that nitrogen in the soil profile towards achieving the region's water quality objectives. And it would be interesting to see how the implementation of that regulation over time could, weigh into or play out in the change in carbon stocks and sinks or sources and sinks for irrigated agriculture. And another one along kind of the water-related lines would be the Sustainable Groundwater Management Act, where land repurposing is being considered as a management strategy to achieve sustainable groundwater management over time. And if land repurposing is done, by some estimates in the San Joaquin Valley, for example, at some pretty big scale, what would that land repurposing look like to go into habitat or other management actions that are being considered, and how would that play into this modeling effort on the carbon side? And then just finally, we work on programmatic permitting with agencies requiring permits for habitat restoration. And so it creates a process that saves time and money to get permits for restoration projects, including really kind of a paradigm shift separate from what development needs to go through for permitting. And we find, permits can take now 30 to 60 days with programmatic ones in place rather than 1 to 3 years. And I wonder if there's a way to model the habitat restoration that can be achieved sooner with programmatic permits in place, and what that would play out in the carbon equation.
Yeah, thanks for all those comments. First, again, please submit those in writing so that we make sure that we include them. But, is it possible to model the things that you're talking about? Yeah, it could be. So we just need to take a closer look at exactly the things that you're referring to. So again, thanks for those comments.
All right, our next question is from John Anderson. John, go ahead.
Okay, thank you for today's presentation, and thank you for the opportunity to comment. John Anderson from Mendocino and Humboldt Redwood Companies. We'll definitely put these in writing, but have a few policy objectives. Number one is trying to get to this 500,000 acres of treatment a year. We're a long ways from getting there, and we really need someone, a person with authority to be put in charge of getting to that point, overseeing treatments and prioritizing the acres to be treated, prioritizing saving lives first, and let's see, and having those be true acres as well. I know the state is trying to grab acres to get to that 500,000 acres, including acres under timber harvest plans. We've had those for 45 years, and we've just seen the wildfire crisis get worse. So these need to be additional to what we've been doing in the past. And certainly close second to that is prescribed fire and taking away the roadblocks to having landowners get fire on the ground. We're going to have fire when Mother Nature wants it, as we're seeing right now, or we can do it when we want to have it on the ground and have that be good fire instead. We're the second largest private landowner in the state. We've done no prescribed burning. We'd love to do it, but the liability is too much. And the issues with the air boards and having very few burn days is also one of the major roadblocks. So we'll put all this in writing. And thank you again for today's presentation.
Great, thank you, appreciate it.
All right, the next question is from Arthur Levine. Arthur, go ahead and unmute yourself and begin.
All right. Hi, everyone. Arthur Levine, calling from the Robert Redford Conservancy for Southern California Sustainability, located in Claremont. I'm just curious how we can add any components related to workforce into these models, particularly about job creation or improvement of the labor force that does all of the work related to land management, from forest firefighters to forest managers to farm workers, both legal citizens who are farm workers and undocumented farm workers. I think that there's a key to getting natural working lands to be put on everybody's priority list by showing that it creates and can create a tremendous amount of jobs, but not just jobs, period, but high road and good jobs that are well paying. I think we'll see a lot more people shifting their careers towards natural and working lands if they feel that it's a worthwhile job. So I'm just curious if there's any way to include that in the models, or to use the ways that we're beginning to value ecosystem services to try to garner support for paying more to people who manage land, et cetera. And especially, again, the boots on the ground workers. I know the scientists and the conservationists and the landowners can receive incentives, but how do we get the incentives down to the laborer, the farm worker, the person who's actually applying compost or biochar to the forest or to the farmlands, harvesting crops and creating the ecosystem services? Thank you.
Yeah, great. Thanks for the comment. So any mechanism can be considered. What we would ask is that you bring that mechanism forward and then tell us how that will change on the ground action, right? Because that's what we're trying to get to with this on the ground action. And again, it can be in the written docket, public docket. I would say also that the California Natural Resources Agency, they had this climate smart strategy that we're considering, and within that, workforce was a component of that, and including, actually mentioned was our undocumented labor force as well. So, but we're still looking for more insights on how to improve working conditions for them, and then how those improved working conditions will help our climate fighting strategy, essentially. So thanks.
All right, our next question is from Dave Marvin. Dave, go ahead.
Thank you. Dave Marvin from Sandville Sciences. Hey, Adam, nice job with the webinar today, and really impressive body of work you guys are putting together. And just no small feat, to say the least. I'm curious, given the different models for different ecosystem or land use types, how are you guys going to integrate across the modeling frameworks, especially when you have transition in and out of different land use types that are specific to certain models, so that you don't end up with, I guess you could call it stranded carbon in different pools under a certain land use type?
Hey, yeah, thanks for the question. So, how natural and working lands shift from one type to another based on conversion. We're still looking for ways to integrate across all of those natural and working land types and switching from one model to another. Like I said, in the long run, our hope is to have one model that kind of just does it all, and then it'll be super easy, right? It will not be super easy. So if you or anybody else has specific recommendations of how to address, this land use change, we're looking for recommendations. So yeah, thanks for the question.
Okay, so then these models are not the final, I guess, like set structure you'll be using ongoing for the next 5 or so years or whatever.
It'll be what we use for the current scoping plan update.
Okay.
And then as we move forward, we'll improve. So thanks.
All right, our next question is from Garland Woodsong. Garland, go ahead. Garland, you're unmuted, but we can't hear you. All right, we're going to go ahead and move on to Jim Stewart. Jim, go ahead.
Hi, this is Dr. Jim Stewart. I'm really impressed with the work of you, Adam, and your team. It's very impressive. I, of course, was disappointed when you said that you're focusing 85% of your time on forest and woodlands. I would like to advocate for coastal wetlands and seagrass meadows. And as you know, AB 32 and SB 32 require consideration of co-benefits. And these coastal have huge co-benefits in terms of coastal protection and nursery for the fishery and all that kind of thing. So how are you considering the co-benefits as you assign CARB staff time to these various options?
Yeah, that's a good question. As I said, we have limited resources and limited time. So that's why we're having to divvy up our time. And that's not to say that we're not ranking things that we think are important. It's just we have to do some sort of prioritization. And so in terms of coastal lands, they are included in our forest and shrubland modeling. All of the riparian zones, at least that are within those watersheds, will be included. What is not included in natural and working lands is blue carbon or any sort of offshore carbon. So that's essentially how we're getting to that. Again, this I guess kind of goes back to the previous question. We're trying to improve as we go along. So those sorts of wetlands along the coast are extremely important, and they're also very complex and hard to model. With time, we will get there and we will address them with the technical expertise that they need and deserve, actually. So thanks for the question.
All right, and Adam, I think this will have to be our last question. So Moises Cisneros, you can go ahead and ask your question.
Wonderful, thank you. I'm calling on behalf of the Sierra Club. Wonderful presentation, thank you so much. Question is around the carbon sequestration that's happening underground. Wondering how that's being captured. I understand through a recent compilation of studies from Dr. Lindsay Rosa and others that the carbon sequestration below ground in California deserts on average are sequestering about almost 10% of carbon sequestration in the state of California. But I don't see that or really was on hand to hear much discussion about that. Was wondering if you're considering that, or is that not possible based on the technology that you're using now to get your data?
Yeah, thanks for the question. Yeah, soils for sure are included. Deserts are mostly inorganic soil carbon, which we had a discussion earlier in the presentation that inorganic soil carbon is not included in our modeling or in our inventory. However, organic soil carbon is. And so that organic soil carbon that will occur in deserts or any natural working land type for that matter will be included in our analysis. And in terms of like forest and shrublands, at least, soil is a major component of the model that we're using. So, thank you.
All right, Adam, I think that's all the questions we have time for. Back to you.
All right, great. I apologize that we just don't have time to get to everybody's questions. So again, I encourage you all to submit to our public docket. And so shown here is the website you can go to get on our listserv. If you don't know where our public docket is, you can just search for California Air Resources Board Scoping Plan Workshops, and then you'll come across our Natural and Working Lands Technical Workshop, which is this one. And then there you'll see the docket that you can submit to. And again, the docket's open until August 3rd, or really like, the very end of August 3rd. And going forward, this is our overall schedule for the scoping plan update. So AB 32 requires that the scoping plan be updated every 5 years. So the statutory deadline to begin the plan before the CARB board for adoption is the end of 2022. The timeline here depicts major milestones we're planning around to meet the adoption deadline. There are still many opportunities to engage in the development process through the scoping plan workshops and the Environmental Justice Advisory Committee meetings and community meetings being planned for later this summer and ongoing through next year. So we're looking towards the release of the draft plan in spring 2022 for about a 45-day comment period, followed by our first of 2 board meetings, and then the release of the final plan in fall of 2022 for proposed adoption by the board by winter 2022. And so thank you everyone for your engagement. And this is really encouraging as we move forward through this process. I hope you are all seeing that we hope to co-create this target with all government agencies and public partners alike. And we are all here because we are passionate about this topic and want the best for California natural and working lands. That's at least the premise that I'm approaching this with. So thank you for attending and have a great rest of your day.